Hello everyone, am I audible? Is the audio okay? Okay then, let's start. So before we start, let me see if anyone has any doubt. So in the comments I can see someone is asking injective surjective function. Okay. And any other doubt? Okay, so let's start the questions, and if any concept comes in any question which we have not covered, then we will cover that concept in that question. Okay, so first we will start with the questions directly. Let me start. So this is the first question. Consider the following statements: for all x px or for all x qx are not logically equivalent, So let's see how to check this. So it is very easy to check actually. You see, for all x px, we already know what it is. It means, let's assume this is the domain. We have already discussed about it, that we need a domain or universe from which this x can take values. So let's assume that your domain, whenever you have such type of question, you can take your domain to have, let's assume, 4 elements a, b, c, d. These 4 elements you can take a, b, c, d. Let's assume these 4 elements are there. Then for all x px, what it means? For all x px means that for every element in the domain, this px must be true, right? For every element in the domain, let's assume that our domain has 4 elements a, b, c, d. Now for every element in the domain, this px must be true. What it means? It means pa must be true, pb must be true, pc must be true, pd must be true. All of them must be true. This is the meaning of this for all x px. This is the meaning, that for every element in the domain, this px must be true, means pa, pb, pc, pd all must be true. So this for all x px, this also can be written, remember, this also can be written as pa conjunction pb conjunction pc and pd. So basically we can write like this: pa and pb and pc and pd. Why I am writing like this? Because you see, this is conjunction, so this is true, pa and pd and pc and pd. It will be true when everyone will be true. This will be true, this will be true, this will be true, this will be true. When everyone will be true, then this and will be true. And that is the meaning of for all quantifier. For all quantifier says that for every element, this px must be true. So remember, this for all x px, this can be written as pa and pb and pc and pd. So you always remember this thing, that this for all x px, how can we write it? Let's assume, if we know what is domain, let's assume our domain is a, b, c, d. Let's assume this is our domain. Then this for all x px, this can be written as pa and pb and pc and pd. This is how you can write this for all x px. Now how can I write there exist x px? How can I write there exist x px? There exist x px says that for at least one element, this px must be true. For at least one element. So I can write like this: either pa must be true, or pb must be true, or pc must be true, or pd must be true. So remember, this for all quantifier can be written in the form of conjunction, in the form of and, you can see. And this there exist quantifier can be written in the form of or. This can be written in the form of or. Why? Because there exist quantifier says that this there exist x px, this will be true when for at least one element in the domain, this px must be true. What it means? It means either pa must be true, or PB must be true, or PC must be true, or PD must be true. If at least one of them is true, then this there exists x px will become true. So this is how we can write, remember, so this is how we can write for all quantifier, this is how we can write there exist quantifier. So now we will use this thing. So now let's assume our domain. So for such questions, what you can do, you can take your domains. Let's take simple domain, only 3 elements we can take. So let's take 3 elements A, B, C. Then now let's see what is this, for all x px or for all x qx. How can I write it? I can write like this, PA or this is for all, so it will be and, so it will be and. I told you that for all quantifier can be written in the form of conjunction, so it can be written like PA and PB and PC, okay, or QA, because this is for all x qx means QA and QB and QC. So this is how you can write this expression, you can write like this, okay. And what is this expression? This expression means PA or QA. This expression will mean PA or QA, this thing, and PB or PB or QB, and PC or QC. This is how you can write. So remember, this expression is this and this expression is this, okay. Is it clear? Because this is for all, so for all can be written in the form of conjunction, okay. And we have just written basically for every element we have written, okay. So now you can just check whether they are same or not. You can very easily check that they are not same, they are not equivalent. Why they are not equivalent? For example, what you do, you make for example, you can make this false, so this will become yes. So what you do, you make this false. Let's assume you make this false, okay. You make this false, and let's assume you make this false, okay. Let's assume you make these two false, you make PC false, QA false, okay. Then what will happen? This complete thing will become false because there is conjunction. This complete thing will become false because there is conjunction, okay. So if you make this false, if you make this false, then this expression, this complete expression will become false. But what you do, you make remaining things true. Then what will happen? You see, because PA is true, so this will be true. Because PB is true, so this will be true. And because QC is true, so this will be true. And this will be true. So you can see this expression will become true. So are you getting my point? I am saying that if you do this, then what will happen? This will become false and this will become true. So we can say that they are not logically equivalent. So this S1 is correct because they are not logically equivalent. So this S1 is correct. So this S1 is correct because they are not logically equivalent. Now let's come to this, there exist. Similarly, you can prove that this is also true. Okay, similarly you can prove that this also is true. How you can prove? See, it is saying that there exist x px and there exist x qx, and this is saying that there exist x px and qx. Okay, so what you can do, let's assume that what you do in your domain, what you do, so this will be true. Yes, in your domain, let's assume you have two elements. In your domain. Then what you do for these elements, what you do, PA you make true, okay, and this QA you make false. Similarly, PB you make true and QB you make false. Okay, let's assume if you do like this, then what will happen? Then this will become false because you can see there exist x px and qx, so this will become false. This still will become true. Why? Because there exist x px, this will become true because of this, and there exist x qx, this will become true because of this. Let's do like this. This is false, this is true. Now, so you can see this will become true because of this. So we can say that this is becoming true, this is becoming false, hence they are not logically equivalent. Okay, and actually this is how you can prove it. Very easily you can prove it. But if you do not want to prove it, then I can give you a table. This table will help you. So you can take this table, let me give you the table. For all there exist, so these are the quantifiers and these are the operators: and operator, or operator, implication operator. Okay, these are the operators you have. And very let's take only these two operators. So for all operator, there exist operator, conjunction and disjunction. So actually this will go both side. Okay, now this will go both side, this will go this side and this will go this side. What it means, let me tell you. So this is the table actually, this is the final conclusion. So for example, if you see what is here we have for all quantifier, also we have disjunction. So basically we are looking at for all quantifier and we are looking at disjunction. So what should we see? We should take this. So it means, you can see this arrow basically means that this arrow basically means, because this arrow is single arrow, so we can say that this is basically not logically equivalent. See, this means logically equivalent, this means not logically equivalent. Okay, so that's why you can see this means that when you have for all quantifier, when you have disjunction, then basically they are not logically equivalent. Similarly, when you have there exist quantifier and you have conjunction, here you can see there exist quantifier and conjunction, in that situation you can see that is also not logically equivalent. But when you have for all quantifier with conjunction, then that is logically equivalent. When you have there exist quantifier with conjunction, there exist quantifier with disjunction, then that is also logically equivalent. So this is the meaning. Okay, and let me tell you what is the meaning of this arrow, like why this arrow and why this arrow. Let me tell you the meaning. The meaning is this: in this table there is a trick, as I told you. In this table there is a trick. Devika is asking, sir, can we take there exist common? No, we cannot take there exist common. Okay, so that is not allowed. You can see this table, how you can remember it. So this table also has a trick. What is the trick? The trick is this: on the left hand side you must have the single you can say the single this quantifier expression. Single quantifier expression means this type of expression, because you can see this is single quantifier expression, this is single quantifier expression. So I can say that on this side you must have single quantifier expression, on this side you must have double quantifier expression. For example, this is double quantifier expression, this is double quantifier expression. So on this side you have double quantifier expression. Now if this expression is involving for all quantifier with, let's assume, conjunction, this expression is involving for all quantifier with conjunction, then you can say that this will go like this because of this. If this expression is basically having for all quantifier with a disjunction, then you will say that this is true but this is not true. Okay, this is true but this is not true. So this is how you can do. Okay, so let me see if anyone has any doubts. Sir, can we use this table for all questions? So actually, whenever you find some trick, then you must know where that trick will apply. Okay, whenever we have a trick, then this is the most important thing, that you must know where that trick will apply. Okay, so let me repeat again where this trick will apply. Let me repeat where this trick will apply. So this trick will apply in these cases. Let me clearly say in which cases this trick will apply. Let's assume you have quantifier for all. Let's assume you have quantifier for all, and inside you have px and qx. Okay, okay, px and qx. This for all quantifier, basically for all quantifier with conjunction, and on the other side you have for all px and for all qx, for all x qx. So again remember, this is for all x px and qx, and in this side what we are doing, basically we are taking this for all inside. Basically we are taking this for all inside and we are applying this for all with p and with q. So you can see we are applying this for all quantifier with p, we are applying this for all quantifier with q. You can see. So in this situation our trick says that for all there exist conjunction, disjunction. Then what is the trick? Trick is like this. So this trick basically says that when you have 4 whole quantifier and you have conjunction, 4 whole quantifier with conjunction, 4 whole quantifier with conjunction, then you can go both side. You can go both side, means this is equivalent to this, because this arrow we have already seen that this arrow means equivalence. So you can say that this is equivalent to this is equivalent to this. Okay, so this is the meaning. Okay, now let's see, you have 4 whole quantifier, let's assume, and with 4 whole quantifier you have disjunction QX. You have 4 whole quantifier and with 4 whole quantifier you have disjunction. Now what you do, you take this 4 whole inside. If you take this 4 whole inside, then what you will get? You will get this 4 whole x px or 4 whole x qx. Basically you took this 4 whole inside. Okay, then you will get 4 whole x px or 4 whole x qx. Now here, remember on the LHS I have written the expression with single quantifier. On the RHS I have written the expression with 2 quantifier basically. Or you can think like this, that this is the shrink expression, like this is a shrunk expression and this is an expanded expression. Basically we have expanded this thing. So you can think like this. Anyway, however you think, basically I am just saying that if you have a trick, then you must know how to use that trick. So you see in this table, this 4 whole quantifier with disjunction, what is happening? It is going in this direction. Basically it is going in this direction. What it means? It means that this RHS will imply LHS, but LHS will not imply RHS. This is the meaning basically. Okay, so this is the meaning. So you can say that this is not equivalent to this, but you can say that this RHS implies LHS. Okay, similarly you can do with there exist. Similarly you can do basically you can write like this, there exist px and qx. Okay, so this is this we are putting on the left hand side, and on the right hand side what I can do, I can take this there exist inside, then I will get there exist x px and there exist x qx. Now you see in our trick you can see there exist, in our table you can see there exist with conjunction is going in this direction, means it is going in this direction. So what it means? It means this LHS will imply RHS, but this RHS will not imply LHS. This is the meaning of this table. So we have seen this table. Now from this table we can very easily answer that these are not logically equivalent and these are not logically equivalent, because our table says that this 4 whole there exist, conjunction, disjunction. This is our table. You can see very easily this is our table, and in this table you can see 4 whole with conjunction, 4 whole with this or 4 whole with this or is basically not going both side, Similarly you can see that there exist with and is not going both sides. So we can say that these are not logically equivalent, So the answer is third option. Let me see if anyone has any doubt. Distribution law not satisfied for or in universal quantifier and for and in existential quantifier. Yes, this table basically says that. This table you can see the interpretation of this table is this only. Okay, you can see this, the interpretation is this only, that what is the interpretation? Interpretation is this: the distribution, basically the distribution law not satisfied by this or in universal quantifier, and this distribution law is not satisfied by and in there exist quantifier. This is the meaning. Okay, Amandeep, did you get? Basically this table is basically representing the thing that you are writing. Okay, so let me see if anyone has any doubt. Sir, not clear. Abdul is saying, Abdul, is it clear now? The table is clear now. Did you get the table now? Okay, let me see if anyone has any doubt. Sir, can't we take so Devika is saying, can't we take there exist common? So Devika, see, when you have this thing, basically when you have this thing, then you can take there exist common. For example, what it means? It means this. There exist x, px or qx, and on the other side you have there exist x, px or there exist x, qx. See, you can see this there exist quantifier with disjunction. It is going both side. When we have this situation, means basically this equivalent situation means going both side situation, then what you can do, you can take this there exist common. So basically you can see if you have this expression, let's assume that you have this expression, then you can take the there exist common and you will get this expression. So this expression will be same as this expression. Okay, but remember you can only do this for these situations when you are going both side. In these situations you can do it. In these situations you cannot do it. Okay, so this is the meaning. Okay, so let me move on, and if anyone has any doubt which I have not cleared, which so you can ask again. Let's see this table. This table is very easy. You already know most of the things. This P implies Q. This can be written like this, P dash plus Q. You already know this thing. You already know that this P implies Q can be written as P dash plus Q. This we have already covered. We have given the proof also. So this P implies Q can be written as P dash plus Q. What is the P dash plus Q? This is P dash plus Q. So A will go with fourth. Okay. This will go with this. Now let's see what is this. What is this third? This third is negation P implies Q. This is third. Negation P implies Q. This we can write like this. The same thing. Now this is our LHS. Remember, this is our LHS. This is our RHS. So what you can do, the same thing you will do. LHS complement plus RHS. Now what is LHS? LHS is P dash. LHS is P dash. So P dash dash plus Q. What is P dash dash? That is P. So you will get P plus Q. So you can see this third will match with B. So this third will match with B. So this A is matching with fourth and this third is matching with B. So our answer, you don't even need to check further. You can directly answer that. Answer will be fourth option. Okay, but of course you can solve remaining things also. For example, let me solve this. What is this? This is basically negation of Q implies P dash. This is now first you solve this. What is this? This is Q dash plus P dash. Okay, because you see this is implication. This is LHS of implication. This is RHS of implication. Then what you will do? You will do LHS complement means Q bar plus RHS. RHS is P dash. Now this complete thing you need to do the complete things complement. So now you can apply the De Morgan formula. What is De Morgan formula? That will be QP means PQ. Okay, so that will be De Morgan formula. So this first will go with C. So this is how you can solve very easily. You can solve this question. The answer will be option fourth. Now this is again a very easy question. What is the which of the following is principal conjunctive normal form for this expression? As I told you, this normal form I left because in digital logic you will study something called SOP, you will study something called POS. These two things you will study in digital logic. Okay, and I told you this SOP is nothing but the so this SOP sum of product. So this sum of product is nothing but the disjunctive normal form, and this POS is nothing but the conjunctive normal form. This we have already discussed. So when you study it there you can solve it. But okay, let me solve it. If anyone want me to solve it, I can solve this right now here. See this. What is this? This is P over Q, and negation P implies negation Q. Okay, this is our equation. You know one thing. You know what is so you know that the precedence. Okay, so you know the precedence. Precedence says that this first you will basically you do this. First you will have to do this. Okay, because this conjunction has more precedence than this implication. We already know this thing, that conjunction has more precedence than implication. We have already seen this thing. So first you convert this. What is this? This is P plus Q multiply this and P dash. This is our this implies Q dash. Now what is this? This thing you can just multiply inside, then you will get PP dash plus QP dash. This you will get implies Q dash. What is PP dash? PP dash is false. With this we have already seen. basically P and P dash, this is always false. Okay, and anything plus false is nothing but that same thing. So basically this will become false plus anything will become this, so you will get QP dash implies Q dash. Now you apply our formula. This is your LHS of implication, this is your RHS of implication. Now what you will have to do, LHS complement, so you will do this LHS complement plus RHS. Now what is this? Here you can apply the De Morgan formula, so you will get Q dash plus P plus Q dash, both this Q dash. So this you will get, finally you will get basically P plus Q dash, this you will get P plus Q dash. So you got P plus Q dash you got. So final expression that you got is P plus Q dash. Okay, so you can just check the answer and the option 1 is true. So this is how you can find it. So any doubt in this? Basically you can solve this question very easily. Okay, let me tell you one more method that you can apply. You don't have to solve it completely. What you do, you eliminate the options. The best method in the exam the best method would be to eliminate the option. What you do, take P equal to true, Q equal to false. Take this, P equal to true, Q equal to false. Take this. So this randomly you take anything, okay, and just eliminate the options. So what this will become, this P or Q will become true. Okay, so you see what is this? This is P or Q and P dash implies Q dash. This, now you see P true, Q false, then this thing will become true and anything will become basically, now this P dash is, because P is true, so P dash will be false. So this complete thing will become false, and because this complete thing has become false, so you know that in implication when this side is false, then automatically this complete thing will become true. So this expression has become true. Now let's check. So you see this also will become true, this also will become true, but what about this? This will become false. So this is not the answer, clearly this is not the answer. Okay, this will become true. So now basically you can take a different case. What you can do, you can take both false. So this is how you can eliminate also. If you do not want to solve the question, then you can eliminate the options also. So you have eliminated the option third. Now if you check this situation, if you take this situation, then you can again eliminate options. You can just for example, when P is false, Q is false, then what will happen? Then again this thing will become false. Again this expression will become true. So this expression will become true, but this option will become false. So you can eliminate this option also. Okay, now you are remaining with two options. Now what you do, you take such a case in which you can eliminate these options. For example, you take P equal to true, you take Q equal to true, you take this case. In this case you check, for example, when you take P true, Q true, then again this P dash, because of this P dash, this expression again will become true, but this will become false. So this is how you can eliminate option fourth also. So you can try this also if you want to. This is your wish. Okay, sometimes this option eliminating helps a lot. So the answer will be basically, I think answer will be option 1. Next, let's see this. What is this? There is a country that borders both India and Nepal. Okay, so this type of expression we have already seen how to convert this type of expression. If you remember, I told you that with there exist quantifier we use conjunction, and with for all quantifier we use implication. If you remember, this we have already seen. So first of all, what we will do, we will convert this statement in our setting. Our setting says that basically there is a country. Okay, there is a country means there exist. What is the meaning of this? The meaning of this is there exist X. Okay, basically there exist X such that is a country, and that borders with both India and Nepal. So basically we are saying that there exists a X such that this X is country. Okay, this X is country, and I told you with there exist we use conjunction. So there exists a X such that X is country, and this X borders with India. So this X borders with India, and this X borders with Nepal. Okay, so this is how you can solve this question, and the answer will be your option 4th. So this will be your answer. Okay, So very easily you can solve it. Anyone has any doubt in this? So I told you that this, with when you have there exist quantifier, then with this with there exist quantifier conjunction comes, and with for all quantifier implication comes. Okay, so this is how you can solve. If anyone has any doubt, then you can ask. So the answer will be option 4th. Next, let's see this. Consider a vocabulary and how many models are there. So this is very easy. What is the definition of model? So when you make the truth table, for example, you have A, B, C, D. You have these four four variable you have, 4 proposition variable you have. Okay, Devika is saying repeat for the last question. See, Devika, I told you that with there exist quantifier we use conjunction. With for all quantifier we use implication. Okay, so here you see this statement, you just rewrite this statement. Okay, this statement is given to you, you rewrite this statement. You rewrite. How can you rewrite? Very easily. You rewrite like this. There is x, there is a x, such that x is a country, okay, x is a country, and x borders with, don't go on my spelling, I am just randomly writing, x borders with India, and x borders with Nepal. So what you can do, basically this statement, this same English statement you can rewrite. Okay, rewrite. So you can rewrite. Now what is the, how can I write this? There is a x. How can I write this? I can write like this. There exists a x. There exists a x. There exists a c. Does not matter. You can use any symbol. So you can write like this. There exists a c. Such that C is a country, means country of C, and C borders with India, and C borders with Nepal. This is the meaning of this statement. Did you get it? Basically this given statement, you can rewrite this statement. Okay, and after rewriting this statement, how can you rewrite? You can rewrite like this. There exists a C. Instead of x you can use C also. You can use any symbol. There exists a C such that C is a country. So you can write like this. C is a country, and C borders with India, and C borders with Nepal. Now you can convert it. How? First you convert this. What is the meaning of this? There is a C. So you can convert like this. There exists a C. Then you can convert C is a country. C is a country means country C. And means conjunction. C borders with India. C borders with India. And means conjunction. C borders with Nepal. C borders with Nepal. Okay. So this is how you can solve. Now let me see. So Nivedita is asking why not third here. See, Nivedita, actually here it is saying that there exists a C such that border of country C, India and Nepal. So country, so you can see here actually nothing is mentioned. Like this is simple, like what is the meaning of this? Actually in this question, see, actually this question is improper. Why this is improper? Because in this question the meaning of this is not mentioned, the meaning of this is not mentioned, the meaning of this is not mentioned. I told you one thing, that we should have predicates. For example, they should mention like this. They should mention like this, that country C means C is a country. They should mention like this. Okay, so that's why actually this question is not, this question is very ill-framed question, because they have not given the meaning of the predicates. They have used the predicates, but they have not given the meaning of the predicates. They have not told us what is the meaning of country C. They have not told us what is the meaning of border C India. Okay, so all these things they have not mentioned. So that's why actually the best guess is option 4th. This is the best guess we can have. Okay, anyway, this is an improper question, but what we can do in exam, if this comes, then the best option will be option 4th. Okay, now let's see this question. before I say this question, let me see. Sir, in first question different. Doctor sir, kindly solve expression q dash p plus q dash. I am little bit. So the expression that Amandeep is asking, q dash p plus q dash. Okay. So you can either use the truth table, or what you can do, you can actually in this expression what you can do, take q dash common, then you will get p plus 1, p plus true, basically p plus 1. P plus 1 is nothing but 1. So finally you will get q and 1. Q and 1 is q dash and 1 is nothing but q dash. So this is how you will get q dash. So this q dash p plus q dash is nothing but q dash. What you can do, basically take the q dash common, then what you will get, you will get p plus 1. P plus 1 is 1. Okay. So now is it clear, Amandeep? Okay. Now let's see this question. In this question, if you see, we have four variables. Okay. Now let me first tell you what is the meaning of model. Let's assume you have two variables. Let's assume you have only two variables. Let's take a easy case and let's assume you have two variable. Now with two variable, how many possibilities are there? See, with two variable, how many possibilities are there? See, this can be either true or it can be false. This can be either true or it can be false. Means this can be either 0 or this can be 1. 0 or 1. So this has two possibilities. This has two possibilities. Total how many possibilities are there? Total 4 possibilities are there. 2 into 2. So what are those 4 possibilities? 0 0 0 1 1 0 1 1. These are those 4 possibilities. Okay. Now let's assume you have an expression. For example, you have this expression A or B. You have this expression. Then what will be the truth table? The truth table will be this. Okay. Now let's assume you have this expression. Let's assume you have this expression. Then what will be the truth table? The truth table will be this. You see one thing. What is the meaning of model? Meaning of model is for how many rows you have true value. For example, you see this A or B. This has true in this row, in this row, in this row. So how many model? We have 3 model. This is model, this is model, this is model. Are you getting my point? The meaning of model means for how many rows, for which row basically you are getting the value true. For example, if you have this function, let's assume if you have this function, then what will happen? Then for this row this will become true, for this row this will become true, for this row this will become true. Okay. So what you can see, you can say that this is model, this is model, this is model. How many model are there for this function? There are 3 model. Now let's check, if you have this function, then how many model are there? See, for the second row it is true, for the third row it is true. So how many model we have? 2 model we have. So this is how you can find how many model are there. Model means basically for how many rows you have true value. So let's check what it is. See, first of all, you can very easily convert it. This is nothing but De Morgan formula has been applied. You can reapply the De Morgan formula and you will get like this: A B C D complement. You will get this ABCD complement. Okay. So very easily you can solve it. How? See, A B C D. When you have 4 variable, then how many rows will be there in the truth table? How many rows will be there in the truth table? There will be 16. Why? It has 2 possibility, it has 2 possibility, it has 2 possibility, it has 2 possibility. What are 2 possibility for A? 0 or 1. For what are 2 possibility for B? 0 or 1. What are 2 possibility for C? 0 or 1. What are 2 possibility for D? 0 or 1. So finally you have total 16 possibilities. Okay. Now what you do? First you make the truth table of ABCD. When you make the truth table of ABCD, then you know this ABCD will be true only in one case, when all are true. In this case this will be true. In all other cases this will be false. You already know this thing. So this is your ABCD, but we are interested in ABCD complement. So just complement it. Basically in this row it will become 0 and in all other rows it will become 1. So basically in this row it will become this ABCD complement will become 0, and in all other rows, how many rows are there? Total 15 rows are remaining. In all these 15 rows this ABCD complement will become true. So this is model. Model means basically in which row our function is becoming true. Okay, so you can see there are total 15 rows in which our function will become true. So this is the answer will be 15. Anyone has any doubt? For example, okay, if you have solved this question, then I can ask you one more question. Let's assume you have this function. Let's assume you have this function a implies b. Okay, you have this function. Then tell me, for this function how many models are there? For this function how many models are there? Tell me, answer this question. You can try this question, let me answer. If you remember the truth table of a implies b, then what you get, a implies b is basically true everywhere except in one case. If you remember, it is true everywhere except in one case. So in this case it is false, in all other cases it is true. So how many model are there? Total 3 model. Remember, when you are checking for a model, then just focus on those rows in which our function is becoming true. So our function is becoming true in 3 rows. So how many model will be there? 3 model will be there for this function. So this is how you can solve this question. Okay, anyone has any doubt, then you can ask. Let me answer it. Consider a vocabulary with only 4 proposition A, B, C, D. How many models are there? So this we have already solved. So how many models will be there? There will be sorry. How many models are there for the following sentences? Now you can very easily answer it. Very easily you can answer this. For example, for this how many models are there? For this A or B, how many models are there? Tell me for this B. How many model will be there? See, there is a trick in this question. You actually yes, now it is correct. So 3 is not the answer. There is a trick here. You missed the trick. The trick is that they have given you 4 variables A, B, C, D. They have given you 4 propositions A, B, C, D. With 4 propositions, how many rows will be there? Total 16 rows will be there. Remember, see, why you did the mistake? Because you were focusing on only A, B. That is why you made the mistake. You should focus on the complete question. The complete question is saying that there are 4 propositions A, B, C, D. Okay. Now, out of so when you have these 4 propositions, then total 16 rows will be there. Now you focus on this A plus B. So this A plus B, basically it does not care about what is the value of C, D. It does not care. It absolutely does not care about the values of C, D. So C, D can take any value C, D can take. So let's see, A plus B. We know this will be false only when this is false, this is false. See, in this case this will be false. In this case, when both are false, in this case this will be false. Okay, so in this case C and D, they can take any value. So how many possibilities? C can take 2 possibility, C has 2 possibility, D has 2 possibility. Total how many possibility are there? Total 4 possibility are there. So these 4 possibility you need to subtract. Out of 16 you need to subtract these 4 possibility, and the answer will be 12. Because why this is true? This is true like this. This A plus B will be true. You can see like this also. This A plus B will be true in which cases? It will be true in this case, it will be true in this case, it will be true in this case. But remember, C, D are also there. C, D are also present. So you focus on them also. But their value does not matter. C comma D, their value does not matter to us, they can take any value. So in this case C can take 2 value, D can take 2 value, so how many? Total 4 possibilities. In this case also 4 possibility, in this case also 4 possibility. In these 12 cases, 4 plus 4 plus 4, in these 12 cases this A plus B will become true. Okay, so is it clear? Similar, so we have solved this question number B. You can solve this question number C also, you can solve this question number A also. Okay, I'll leave it up to you. You can very easily solve it. Okay, there is no but you just have to use your brain. And but just for example, when you are solving this option C, then don't forget about this D. Okay, because in option C you have A by implication, B by implication, C. Okay, so when you are answering for this, then you should also consider D. The value of D will not matter to us. You can take any value of D, that does not matter. Okay, so that's why you can take any value of D. So okay, you can solve this question. I have confidence on you. So, actually I am not solving all these questions, because once we solve a question on one template, then you can try other questions, so that we can cover more templates. Okay, and what is this question? In this question basically he has given the truth table. For example, this truth table is given. When the complete truth table is given, then you can directly answer how many model are there. This is model, this is model, this is model, 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 model. So how many model are there? 1, 2 and these 3, 2, 5, 7 total. So 7 model will be there. Okay, so anyway, you got the concept. Now let's move on. In mathematical logic, which of the following are statements? Remember, this statement is same as proposition. So we mostly use this word proposition, but this statement, proposition, both are same thing. Okay, so you already know what is a proposition, what is not a proposition. For example, there will be snow in January. This is a proposition. What time it is? This is not a proposition, because this is a question. You see, this is a question. What time it is? This is a question. Okay, this is not a declarative fact. Today is Sunday. This is a this is a proposition. You must study discrete mathematics. This is a command. You must study discrete mathematics. This is a command. You can't say yes or no, for example. Okay, so that's why the answer will be 1 and 3, and the answer will be 1 and 3. Yes, answer will be option C. Okay, did you get it? So remember, this option 4th is a command. Basically, maybe I am commanding everyone that you must study discrete mathematics. Few days ago, I told someone this line: you must study discrete mathematics. Actually, he was trying to study TOC without studying discrete mathematics. So without studying discrete mathematics, he directly started studying TOC. That's why I told him that before studying TOC, you must study discrete mathematics. So this statement I have already used 2 days back. Anyway, this is not a proposition, because this is a command. Okay, if anyone has any doubt anywhere, then you can quickly ask. Okay, in NET exam, I don't know why these model questions are asked so frequently. You can see so far we have seen 3 questions on models. But anyway, you can very easily solve these questions. So but focus on this thing. Some students are basically not focusing on this thing, that there are 4 propositions here, A, B, C, D. There are 4 variables here. Now he is asking how many models are there for B or C. It will be answer 12. This is same as B or C. Okay, how many? Either 1, 0 or 0, 1 or 1, 1. In this case, total 4 possibility, because the variable A comma D, this variable can take any value. Okay, also let me tell you one thing, that so some students have requested that I should take at least one example in Hindi. So I will do that. From now onwards I will do that. So okay, from now onwards what we will do, once we have seen a template, once we have seen a question, then if the similar question comes, then this next question I will take in Hindi. So the first question I will take in English, and the next question I will take in Hindi whenever we have a same question. For example, this is the same question, so let me take this question in Hindi. तो यहाँ पे आप देख सकते हैं कि कितने वेरिएबल हैं हमारे पास में, 4 वेरिएबल हैं, A, B, C, D, 4 वेरिएबल हमारे पास हैं, लेकिन क्वेश्चन के अंदर उसने पूछा है B और C. ओके, तो जब आप B और C को, सिर्फ B और C को नहीं देखना है, A, B, C, D चारों को देखना है. ओके, तो फिर अब बी और सी, अब ये ट्रू कब होगा, हम जानते हैं ये ट्रू होगा जब ये 0 ये 1 हो, ये 1 ये 0 हो, ये 1 ये 1। सो इन तीन केसेस में ये ट्रू होगा, ये ट्रू हो जाएगा। सो ये जो बी और सी है ये ट्रू हो जाएगा इन तीन केसेस में। वी डू नॉट केयर, ओके, ए की वैल्यू और डी की वैल्यू उनसे हमें फ़र्क नहीं पड़ता है, दे कैन टेक एनी वैल्यू, ओके। तो फिर ए जो है वो दो वैल्यू ले सकता है, आइदर ए कैन बी 0, ए कैन बी 1, डी कैन बी 0, डी कैन बी 1। सो यू कैन सी दैट्स वाई इस केस में जब बी 0 है सी 1 है, इस केस में ए ये दो पॉसिबिलिटीज़ ले सकता है, डी ये दो पॉसिबिलिटी ले सकता है। तो टोटल इस केस में टोटल 4 पॉसिबिलिटी है, और ये सारी की सारी जो 4 केसेस हैं, 4 पॉसिबिलिटी है, दे विल बेसिकली गिव अस ट्रू वैल्यू। सो दैट्स वाई all these 4 cases are models. Similarly here also and similarly here also, okay. Okay, Devika is saying, and if next doesn't come, okay, so actually if we repeat the same question in first in Hindi, first in English then in Hindi, तो फिर बहुत सारा मतलब टाइम जो है वो बहुत सारा निकल जाएगा। तो लेट मी हैव सम डिस्कशन विद अब्दुल सर एंड वी विल सी व्हाट सॉल्यूशन वी कैन डू। ओके, चलिए लेट्स सी दिस क्वेश्चन। कंसिडर द फॉलोइंग स्टेटमेंट, विच ऑफ द फॉलोइंग इज करेक्ट विद रेस्पेक्ट टू द अबव स्टेटमेंट्स। सो ओके, दो स्टेटमेंट दिए हुए हैं, फॉल्स ट्रू इफ अल्फा देन अल्फा। व्हाट इज द मीनिंग ऑफ दिस, आई डोंट नो। व्हाट इज दिस ऑपरेटर, फ्रॉम वेयर दिस नेट एग्जाम पीपल हैव कम अप विद दिस ऑपरेटर। व्हाट इज दिस ऑपरेटर, इज दिस प्लस? आई थिंक दिस इज प्लस, आई थिंक दिस इज प्लस, आई थिंक, इज दिस प्लस? Okay, one second. Abdul is saying that how see Abdul B C, now ये एक केस है, ओके, दिस इज वन केस 0 1, लेकिन जब B की वैल्यू 0 है, C की वैल्यू 1 है, जब ऐसा है तब A की वैल्यू D की वैल्यू कुछ भी हो सकती है। A की वैल्यू 0 हो सकती है, 1 हो सकती है, D की वैल्यू 0 हो सकती है, 1 हो सकती है। तो इनके वजह से टोटल 4 केस बन जाएंगे। आर यू गेटिंग दिस पॉइंट अब्दुल? बी और सी की तो वैल्यू फिक्स है, बी की वैल्यू 0 है, सी की वैल्यू 1 है, वो तो फिक्स है, लेकिन ए की वजह से, डी की वजह से टोटल 4 केस बन जाएंगे। इन चारों केसेस में बी की वैल्यू 0 है, सी की वैल्यू 1 है, ओके। इन चारों केसेस में बेसिकली बी और सी विल बिकम ट्रू। इन चारों केसेस में बी और सी विल बिकम ट्रू। दिस इज व्हाट वी वांट। Okay, did you get it, Abdul? Is it clear? So I think this is or, this operator. So this again is like a very ill-framed question. They should define what is this operation. See, this is not a standard operator. The standard operator is this, or they can use this. These are standard operators. But anyway, from the question I can feel that this is or. So now the first option is false plus true. फॉल्स प्लस ट्रू क्या होगा? फॉल्स प्लस ट्रू तो ट्रू होता है, यू ऑलरेडी नो, फॉल्स प्लस ट्रू ट्रू। लेट्स सी दिस, व्हाट इज दिस? दिस इज बेसिकली अल्फा प्लस बीटा गामा, अल्फा प्लस बीटा गामा, ओके। ही इज सेइंग दैट अल्फा प्लस बीटा गामा, दिस कंप्लीट थिंग is implying alpha plus beta and alpha plus gamma. Okay, I can't write even gamma. I can't write anyway. So this is your option B. Now so what can you say about this option B? Alpha plus beta gamma implies alpha plus beta and alpha plus gamma. So actually ये एक डिस्ट्रीब्यूटिव प्रॉपर्टी है, जो कि एक डिस्ट्रीब्यूटिव प्रॉपर्टी है, मतलब स्टैंडर्ड प्रॉपर्टी है। basically a plus bc, a plus bc. What you can write it like this: a plus b and a plus c. This is how you can write. So this is the standard distributive property. Actually we can very easily prove it. Let me prove it. So we can very easily prove it. क्या कह रहा है ये? सी whenever you have this type of equation a plus bc, तो इसे आप कैसे लिख सकते हैं? इसे आप लिख सकते हैं a plus b and a plus c. Okay, let me know one thing. Total 33 students are here. Tell me one thing. चलो ठीक है, कुछ स्टूडेंट्स को इंग्लिश से थोड़ी प्रॉब्लम है, ठीक है, वो ठीक है. ऐसा कोई स्टूडेंट है जिसे हिंदी से प्रॉब्लम है? ऐसा कोई स्टूडेंट है तो अभी कमेंट बॉक्स के अंदर कमेंट बॉक्स में कैपिटल्स में यस लिख दो. कैपिटल्स में यस, YES कैपिटल में ये लिख दो. मुझे पता चल जाएगा कि हिंदी से किसी को प्रॉब्लम है. ओके, टेल मी, जस्ट गिव मी दिस इंफॉर्मेशन whether you have problem with Hindi. Okay, just tell me. So कैपिटल्स में यस लिख दो ताकि मुझे पता चल जाए कि आपको हिंदी से प्रॉब्लम है. मे बी सम साउथ इंडियन स्टूडेंट मे बी देयर. एनीवे, so this is a distributive property. A plus BC is equal to A plus B and A plus C. Very easily with the truth table you can solve it. Okay, or what you can do, you can just expand it. You can just, what you do, multiply it. So first you multiply this A with A plus C, then what you will get? A into A. A into A is nothing but A plus AC plus BA plus BC. Then this, actually this A plus AC, this will become A. Why? Because you take A common, then inside you will get A 1 plus C. So this 1 plus C is nothing but 1. Okay, this 1 plus C, this will become 1. So finally this will become A. Now this will become A plus BA plus BC. Okay, so this A plus BA, it will also become A. So finally you will get A plus BC. Are you getting my point? So let me, you can very easily prove it. Let me give you some results. This is important result, A plus AB. Whenever you have this type of equation, no yes has come. Okay, देविका, no yes has come. So ठीक है, हिंदी में कंटिन्यू कर सकते हैं, मिक्स कर सकते हैं. तो चलो A plus AB, all the technical terms, सारी जितनी भी टेक्निकल टर्म्स हैं उनको हम इंग्लिश में बोलेंगे और बाकी जो कन्वर्सेशन है वो हिंदी में कर सकते हैं. एनीवे, A plus AB, whenever you have this type of equation, then this is nothing but A. क्यों? क्योंकि आप A को कॉमन ले सकते हैं. A को कॉमन ले लीजिए तो यहाँ पे बचेगा 1 और यहाँ पे बचेगा B. तो 1 plus B is nothing but 1. Okay, so finally you will get A. So remember this equation, A plus AB, that is equal to A. Or you can say like this, A plus A, फिर कुछ भी हो सकता है यहाँ पे. फिर यहाँ पे आप कुछ भी रख सकते हो, मतलब यहाँ पे आप कुछ भी रख दो, फर्क नहीं पड़ता. कुछ भी रख सकते हो आप, कुछ भी रख सकते हो. तो जो फाइनल रिजल्ट होगा वो A होगा. सिमिलरली when you have A plus A dash, और फिर आप यहाँ पे आप कुछ भी रख सकते हो. फॉर एग्जाम्पल लेट्स अज्यूम कुछ भी आपने रख दिया, कैपिटल M आपने रख दिया, तो what it will be? It will be basically the final result will be A plus M. So basically this will be removed. Whenever you have this A plus A dash M, whenever you have this, तो क्या हो जाएगा? A dash को आप रिमूव कर सकते हो, तो finally you will get A plus M. So this easily you can prove it with truth table you can prove it. And what is another thing? Another thing is A plus AB. A plus BC. A plus BC. A plus BC is nothing but, this is distributive property. तो हम क्या कर सकते हैं? A plus B and A plus C. तो ये डिस्ट्रीब्यूटिव प्रॉपर्टी है. तो एक्चुअली आप देखोगे ऑप्शन बी जो है वो बस डिस्ट्रीब्यूटिव प्रॉपर्टी ही है. ओके, दिस ऑप्शन बी इज डिस्ट्रीब्यूटिव प्रॉपर्टी. बेसिकली ये कह रहा है कि ए अल्फा प्लस बीटा गामा इज नथिंग बट अल्फा प्लस बीटा एंड अल्फा प्लस गामा. सो ये डिस्ट्रीब्यूटिव प्रॉपर्टी है. तो हम कह सकते हैं कि बोथ स्टेटमेंट ए एंड बी आर ट्रू. सो बोथ स्टेटमेंट आर ट्रू. आंसर विल बी फोर्थ ऑप्शन. Okay, so Prerna is asking how many model will be there for this question. Okay, let me solve this. So Prerna is asking how many models will be there for this equation. तो पहले तो what is the behavior of this operator you must understand. We have already seen this operator. ये ट्रू कब होता है? ये ट्रू होता है जब ये भी ट्रू हो, ये भी ट्रू हो. ओके जब ये भी ट्रू हो, सॉरी जब ये बेसिकली बोथ हैव सेम ट्रूथ वैल्यू, ये ट्रू या फिर ये फॉल्स, मतलब कि दोनों की सेम ट्रूथ वैल्यू होनी चाहिए, सेम ट्रूथ वैल्यू होनी चाहिए दोनों की, ठीक है। तो उस सिचुएशन में हम कहेंगे कि ये ट्रू है, ठीक है। तो आप ये देखो ये इसको हम ऐसे लिख सकते हैं, वेट अ सेकेंड, इसको हम कैसे कर सकते हैं कि दिस बी सी, नाउ लेट्स take the situation, let's assume that C is false, let's assume C is false, okay। जब C false होगा तब क्या होना पड़ेगा, अगर C false है तो इसको भी false होना पड़ेगा, और इसको false होने के लिए कितनी possibilities हैं, टोटल 2 possibility हैं इसके false होने के लिए, लेकिन remember the D is not here। See what I am doing, I am basically dividing this question in cases, in different cases I can divide this question। The first case is what will happen when C is false, what will happen in this case। जब C false है तो अगर मैं फाइनली अगर इस पूरी चीज़ को ट्रू बनाना चाहता हूँ तो क्या होना पड़ेगा, इस चीज़ को भी false होना पड़ेगा, ताकि false डबल इम्प्लाइज false, टोटल क्या बन जाएगा, ट्रू बन जाएगा। तो इसको भी false होना पड़ेगा। इसको false होने के लिए कितनी पॉसिबिलिटीज़ हैं, 2 पॉसिबिलिटी इसको false होने के लिए, इसको false होने के लिए 2 पॉसिबिलिटी है। ये ट्रूथ टेबल में आप देख सकते हो, इसको false होने के लिए 2 पॉसिबिलिटी है। लेकिन रिमेंबर डी जो है वो कोई भी वैल्यू ले सकता है, तो डी के लिए भी 2 पॉसिबिलिटी हो गई। तो इसका मतलब टोटल कितनी पॉसिबिलिटी हो गई, टोटल 4 पॉसिबिलिटी। तो इसका मतलब जब सी फॉल्स है तब 4 पॉसिबिलिटी हैं इस पूरी चीज़ को ट्रू बनाने के लिए। इस पूरी चीज़ को ट्रू बनाने के लिए कितनी पॉसिबिलिटीज़ हैं, टोटल 4 पॉसिबिलिटीज़ हैं इस पूरी चीज़ को ट्रू बनाने के लिए। नाउ अब आप क्या कर सकते हो, तो हमने सी को फॉल्स लेके देख लिया, अब हम सी को ट्रू लेके देख लेते हैं। अगर सी ट्रू है तो इस पूरी चीज़ को ट्रू बनाने के लिए हमें क्या करना पड़ेगा, हमें इस चीज़ को ट्रू बनाना पड़ेगा। इस चीज़ को ट्रू बनाने के लिए कितनी पॉसिबिलिटीज़ हैं, फिर से 2 पॉसिबिलिटी हैं। लेकिन रिमेंबर डी के पास भी 2 पॉसिबिलिटी हैं, तो टोटल कितनी पॉसिबिलिटी हो गई, फिर से 4 पॉसिबिलिटी हो गई, तो टोटल 8 पॉसिबिलिटी। सो हाउ मेनी मॉडल विल बी देयर, टोटल 8 मॉडल्स विल बी देयर। इज दिस डाउट क्लियर, इज दिस आंसर क्लियर, is this clear answer? प्रेरणा ये क्लियर है, इज दिस क्लियर दैट टोटल 8 will be there। very easily you can solve it, just divide this question in different cases। एक बार सी को फॉल्स ले सकते हैं, एक बार सी को ट्रू ले सकते हैं, ठीक है। जब सी को फॉल्स लिया तब हमें पता चला कि टोटल 4 मॉडल हैं। जब सी को ट्रू लिया तो हमें पता चला कि टोटल 4 मॉडल हैं। तो टोटल कितने, 8, टोटल 8 मॉडल हो गए। आंसर विल बी 8 फॉर दिस क्वेश्चन, आंसर विल बी 8। ओके, नाउ लेट्स मूव ऑन। ओके तो इतना देख लिया। अभी ये क्या है, कंसिडर द फॉलोइंग इंग्लिश स्टेटमेंट, आगरा एंड ग्वालियर आर बोथ इन इंडिया। नेक्स्ट, a student has written a logical sentence for the above English sentence in first order logic using predicate UC। ये देखिए, ये क्वेश्चन अच्छा है क्योंकि उसने उसने बेसिकली प्रेडिकेट को भी डिफाइन किया है। क्या कह रहा है, इन एक्स वाई विच मीन्स एक्स इज इन वाई। तो देखिए इस क्वेश्चन में और पहले वाले क्वेश्चन के अंदर थोड़ा सा फर्क है ना, इसके अंदर उसने प्रेडिकेट को भी डिफाइन किया। तो ये क्वेश्चन मतलब अच्छा है, ये अच्छा क्वेश्चन। तो इसमें क्या कह रहा है कि इन एक्स वाई, इस प्रेडिकेट का मतलब है एक्स इज इन वाई। फाइनली ये क्या कह रहा है कि आगरा इंडिया में है और ग्वालियर इंडिया में है। आगरा इंडिया में है और ग्वालियर इंडिया में है। ओके, तो अब सुनो, अब देखो ये जो ओरिजिनल जो सेंटेंस है वो क्या कह रहा है, ओरिजिनल सेंटेंस कह रहा है कि आगरा एंड ग्वालियर दोनों इंडिया में है। ये तो ओरिजिनल सेंटेंस कह रहा है। तो ओरिजिनल सेंटेंस अगर मैं किसी को ओरिजिनल सेंटेंस बोलूँ तो उसे क्या पता चलेगा, उसे पता चलेगा कि आगरा भी इंडिया में है, ग्वालियर भी इंडिया में है। तो उसे तो ये पता चलेगा कि ये इंडिया है और इस इंडिया में आगरा भी है और इस इंडिया में ग्वालियर भी है, ठीक है, इंडिया में। अब अगर मैं किसी को अगर ये सेंटेंस बोलूँ कि आगरा इंडिया में है या ग्वालियर इंडिया में है, तो उसे क्या पता चलेगा, उसे ये पता चलेगा कि या तो आगरा इंडिया में है, ठीक है, या फिर ग्वालियर इंडिया में है, या फिर हो सकता है दोनों इंडिया में हो, समझ रहे हो। तो अब देखो, तो दोनों जो सेंटेंसेस हैं वो बेसिकली डिफरेंट हैं, दोनों सेंटेंसेस अलग हैं, ठीक है। ऑफ कोर्स ये करेक्ट है, मतलब ये देखो अगर ये करेक्ट है तो ये भी करेक्ट है, क्योंकि अगर आगरा और ग्वालियर अगर दोनों इंडिया में है तो इसका मतलब है कि ये भी करेक्ट है, ये भी करेक्ट है, ये भी करेक्ट है। इसका मतलब अगर ये ओरिजिनल सेंटेंस अगर करेक्ट है तो ये भी करेक्ट है, ठीक है। तो हम कह सकते हैं कि ये जो सेंटेंस है ये सिंटैक्टिकली करेक्ट है, लेकिन ये डज नॉट एक्सप्रेस द मीनिंग ऑफ द इंग्लिश सेंटेंस, सो आंसर विल बी फर्स्ट, क्योंकि ये बेसिकली ये करेक्ट है, मतलब ये जो स्टेटमेंट है ये करेक्ट है, लेकिन ये जो स्टेटमेंट है ये इस स्टेटमेंट का मतलब एग्जैक्ट सेम नहीं है, समझ रहे हो। इज दिस क्लियर? ओके, if anyone has any doubt then you can ask. Is this doubt clear? Is this question clear? In this question basically what is happening, that this statement he is saying that both Agra and Gwalior are in India, and this statement is saying that either Agra is in India or Gwalior is in India, or Agra and Gwalior both are in India. Okay, तो आप देख सकते हो, you can see that this statement and this statement are different. First of all they are different, okay, but this statement, if this statement is true then automatically this statement is also true, because if both Agra and Gwalior are in India, then you can say Agra is in India, Gwalior is in India, Agra and Gwalior both are in India. So that's why if this is true then this is also true, but both are different, so that's why we can say that it is syntactically valid but does not express the meaning of the English sentence. Let's see this question. What is this? So if x yes then y unless z, तो ये हमने ऑलरेडी सॉल्व किया हुआ है। मैंने बोला था कि अनलेस का जो मतलब होता है वो क्या होता है, और unless has the same meaning as or. This we have already covered in our lecture. Now what is this statement? This statement is basically if x then y unless z. Okay, so what is the meaning of this statement? This statement has the meaning if x then y, if x then y unless z, unless z. So this type, for example, you can think of this statement as some mother is saying that if you study then I'll let you go play unless today is holiday. Okay, maybe this statement, are you getting this point? So how can you convert it? Very easily you can convert it. This unless means plus, and what is the meaning of this? This is x implies y, so x implies y plus z. Okay, so finally this you will get, and so this you will get x dash plus y plus z. This you will get x dash plus y plus z. Now let's check which of the options is x dash plus y plus z. Which of the options is x dash plus y plus z? So you can just check. You can just check this is not, and you can just check this is yes. This is correct, because if you check this then you will get this. This is nothing but x and z dash total dash plus y, and now you use the De Morgan formula, then you will get x dash plus z plus y. So this is what we wanted, so answer will be option 2. Is this clear? We have already seen this thing. Whenever you have this type of statement, you think of this statement as some mother is saying that if you study then I'll let you go play unless today is holiday. Okay, so you can think of this as like this, and this unless is nothing but plus, so this is plus z, and this complete thing is nothing but x implies y, and now this is nothing but option 2. Okay, if anyone has any doubt then you can ask. Now let's see this question. Actually this question is from actually this there is a problem. There is a slight problem with NET exam, ISRO exam. All these exams, if you see NET exam, there is ISRO exam. These exams, if you see, they do not make original questions. Okay, if you see this exam, GATE exam, or TIFR exam, these exams, if you see, they make original questions. Like their questions are not copied from anywhere. NET exam, ISRO exam, these exam make questions which are copied from somewhere. Like this question I had solved in 2016. I had already solved. तो 2016 में मैं ऑलरेडी इसको सॉल्व कर चुका था और ये 2017 में ये आया है. तो मतलब एज इट इज़ ये क्वेश्चन एक फॉरेन यूनिवर्सिटी के किसी एग्ज़ाम से है, शायद कोई फॉरेन यूनिवर्सिटी है उसके किसी एग्ज़ाम से ये क्वेश्चन कॉपी किया गया है. तो मतलब ये प्रॉब्लम है. मतलब नेट एग्ज़ाम और इसरो एग्ज़ाम, इसरो में भी ऐसा ही है. लोग सोचते हैं इसरो महान, इसरो वो. इसरो महान है लेकिन इसरो की जो एग्ज़ाम है वो महान नहीं है. इसरो इज़ ग्रेट बट द एग्ज़ाम इज़ नॉट ग्रेट. ये कॉपी करते हैं, मतलब कहीं गेट से कॉपी कर लिया, कहीं और से कॉपी कर लिया, यहाँ से कॉपी कर लिया, वहाँ से कॉपी कर लिया. कॉपी करने में भी दिक्कत नहीं है, लेकिन कई बार ये सही से कॉपी भी नहीं करते हैं. ठीक है, ये कई बार आधा क्वेश्चन कॉपी कर लेते हैं. तो एक यूनिवर्सिटी का एक एग्ज़ाम था, उसके अंदर क्वेश्चन था और वो पूरा 1 पेज का क्वेश्चन था. इसरो वालों ने इतना सा क्वेश्चन कॉपी कर लिया, बाकी इतना क्वेश्चन कॉपी नहीं किया. ठीक है, तो ये ऐसा कई बार हो जाता है. एनीवे, लेट्स वी डोंट केयर अबाउट इट. So anyway, let's solve this question. Our only concern is to solve the question. What is this? He's asking, consider the following and which of them is satisfiable, which of them is valid. See, you already know what is the meaning of satisfiable. You already know the meaning of satisfiable. Satisfiable का क्या मतलब है? Satisfiable means either tautology or contingency. You already know this thing. Okay, you already know this thing. Unsatisfiable का क्या मतलब है? Unsatisfiable का मतलब है contradiction. You already know this thing. तो ये तो है satisfiable का मतलब, ये है unsatisfiable का मतलब. अब valid का क्या मतलब है? Valid का मतलब है tautology. Valid का मतलब है tautology. So remember this. The satisfiable means either tautology or contingency. Unsatisfiable means contradiction. Valid means tautology. Okay. So remember this point. Valid means tautology, or you can say true. Valid, tautology, true. All these things are same. Valid, tautology, true. Okay. So now let's see this statement F1. Very easy. Just convert it. It will be P dash plus P dash. Finally it will be P dash. तो ये P dash क्या है? ये तो contingency हो गया ना. P dash is contingency. So basically this is not valid. You can see this is not tautology. First of all, this is not tautology. So this is not valid, but this is satisfiable because this is satisfiable. This is satisfiable. Okay, this is satisfiable because this is contingency. Now let's see what is this. This is nothing but, first of all we will convert it. What is this? This is nothing but P dash plus P dash, or what is this? This is nothing but P plus P. Now what is P dash plus P dash? That is P dash plus P is nothing but P. P plus P dash is nothing but true. True means tautology. True means valid. So you can say that F2 is valid, F1 is satisfiable. Answer will be option 1. Okay, did you get it? Is it clear? F2 is valid and okay. So sir, in previous question, as per operator precedence, or is having higher precedence than, then it will be the expression. Rahul, there is I got your doubt. Rahul, a brilliant doubt you have asked. But see, this is an English statement. English statements are ambiguous. Okay, English statements are ambiguous. The operator precedence that we are talking about, that we apply when we have a formula, when we have a mathematical logic formula. For example, if I give you this formula, then you can apply the operator precedence. Okay, now you can apply the operator precedence. But लेकिन अगर मैं तुम्हें एक English statement दूँ, ये एक English statement है. That's why English language is so much ambiguous. Like I got your doubt actually, but the thing is, this has become your doubt is clear. Actually, this is an ambiguous statement because we converted it like this. But actually, this could also be converted like this also. Okay, like because this English language is ambiguous, so you can maybe you can have this, or maybe you can have this. but actually here is the thing, that this has become a standard, that this unless, most of the time this unless is used with conditional statement. Okay, most of the time this unless statement is used with a conditional statement. You can see in your English, whenever you are speaking, okay, whenever you are speaking in your general, in your regular life, and if you use this unless word, then you also use this unless word with implication. For example, you might say like this, okay, अगर हम जल्दी जाएंगे तो ट्रेन को पकड़ लेंगे, unless ट्रेन लेट हो जाए, ठीक है। तो इस तरह की स्टेटमेंट्स, मतलब हम कंडीशनल स्टेटमेंट्स के साथ में हम unless यूज करते ही हैं, ओके। तो ये एक स्टैंडर्ड बन चुका है कि unless जो है वो कंडीशनल स्टेटमेंट्स के साथ में यूज होता है। तो अब तुम्हारा जो कंडीशनल स्टेटमेंट है वो ये है, देन वाई, इफ एक्स देन वाई अनलेस जेड। तो ये एक स्टैंडर्ड बन चुका है कि बेसिक योर स्टेटमेंट इज बेसिकली दिस, बट दिस इज अनलेस कंडीशन। इट्स लाइक दिस, अगर हम जल्दी जाएंगे तो ट्रेन को पकड़ लेंगे अनलेस ट्रेन लेट हो जाए। तो योर ओरिजिनल स्टेटमेंट इज दिस, योर मेन कंसर्न इज दिस, कि अगर हम जल्दी जाएंगे तो ट्रेन को पकड़ लेंगे, योर मेन कंसर्न इज दिस। But this unless is basically providing more flexibility. This unless is saying that unless train ही late हो जाए, या फिर आप ये, or you can see like this, if you study then I will let you play unless today's holiday. Okay, so that is the that is a standard. It has become a standard. So operator precedence is applied when you have a mathematical statement. Whenever you have mathematical formula, then we apply the operator precedence. Okay. English statements are ambiguous, but this unless statement is, most of the time we use this unless statement with a conditional statement. So basically we have a conditional statement, this is our conditional statement, then we have unless, and then we have statement. So this is how we will look at it. Okay, is it clear, Rahul? Okay, so anyone has any doubt? So much chat you do, I can't even see if anyone has any doubt or not. Okay, Manisha is asking how F2 is tautology. How F2 is tautology. So let's see. Manisha, first of all, you look at it. P implies P dash. We know this thing, that whenever we have this kind of statement, P implies something. Whenever we have this kind of statement, okay, basically LHS, implication का LHS ये है, implication का RHS ये है. Then this can be written as P dash plus Q. You know this thing that this can be written as P dash plus Q. So same we will do here. First we will convert it. So this will become P dash plus P dash. Okay. Then we have OR. Then we have this. This will become, basically when you do this, so it will become P plus P. Is it clear? Now P plus P is nothing but P. Or P dash plus P dash is nothing but P dash. P plus P dash. Now what is this? This is P plus P dash. P plus P dash is true. P plus P dash is true. This we have already seen actually, that P plus P dash is true. P and P dash is false. All these things we have already seen. P plus P is equal to P. P and P is equal to P. P plus true is equal to true. P and true is equal to P. All these things we have already seen. Manisha, is it clear? No, yes, P dash plus P. P dash plus P is nothing but true. True means tautology. True means tautology. True means valid. So that is the meaning. Every valid formula is satisfiable. So I can see some people are discussing. So let me tell you, valid means tautology. Valid means tautology. Tautology means true. Satisfiable means either tautology or contingency. Okay, so you can see every valid thing is satisfiable, but satisfiable thing may not be valid. Okay, so anyway, let's move on. This is a easy question, very easily you can solve it. And what is this? This is basically, you have P implication Q and its negation. What is this? From the truth table also you can see, or you can look at here. This is actually nothing but P XOR Q. So from the truth table also you can see very easily, you can solve the you can see from truth table, you see 0 0 0 1 1 0 1 1. Now this will be 1 0 0 1. Now if you complement it, because he is basically complementing this, then what you will get? You will get 0 1 1 0. What is this? This is nothing but P XOR Q. So you can see that complement of I told you one thing, if you remember, I told you one thing, that this is nothing but XNOR. If you remember, I told you this thing, that this is nothing but XNOR. In Boolean algebra we have XNOR, in propositional logic we have by implication. So the by implication of propositional logic is same as XNOR. Okay, and in digital logic you will study this thing again, you will study this thing, that whenever you have XNOR and you complement it, then you will basically get XOR. So you will basically get XOR. Okay, now all you have to do is which of these statements is like, you just need to see. So XOR you already know. XOR is true when basically both are different. Then it is true. So this answer is, this is not correct. This is correct. No, wait a second. This also is not correct. Okay, this also not. Yes, this is correct actually. No, wait a second. Is equivalent to what he is saying. Wait a second. This is. So the answer will be. The answer will be this. You can see from the truth table also. You can see, if you make, for example, if you make the truth table PQ 00011011, then if you make the truth table for this, then what you will get? You will basically get. So wait a second. So the truth table here will be 11100100, and finally you will get 1001. No, this is not correct. So answer is both actually. Answer is 1 and 2. So both are answer. Both are correct. 1 and 2 are correct. This is not correct. This is not correct. 1 and 2 are correct. And so actually 2 options are correct in this question. Okay, let's see some properties you can see. XNOR, P XNOR Q complement. What is this P XNOR Q complement? This is nothing but P XOR Q. Also this same thing, this P XOR Q you can write like this also, P dash Q plus PQ dash. Okay, this P XOR Q. Similarly, this P XNOR Q you can write like this, P dash Q dash plus PQ. So if you see, when you change both, when you complement both of them, then what you will get? You will basically again get the same thing, because when you complement both of them, then you will again get the same thing. That's what we are saying. I am saying that basically this P XNOR Q is basically same as P dash XNOR Q dash. Okay, from this formula, these formulas are very nice formula, and you will see all these formulas in digital logic. So the first formula that you will see in digital logic is that P XOR Q is nothing but P dash Q plus PQ dash. Okay, also you will see that P XNOR Q is nothing but PQ plus P dash Q dash. So these two formula are also important, but this formula I did not cover because you will again study them in digital logic. In digital logic you will study this Boolean algebra. There you will study all these things. Just remember that this by implication is same as XNOR. Khusbu is asking this doubt that I was getting 1, 2, 3 for this. No, the third won't be true. See, the third, this third is nothing but this third option is nothing but P double implies Q. Okay, so this third is not answer, because in the original question he is asking the complement of this thing. And this is a easy question. This is a very easy question. There is an ambiguity. Basically, answer will be 1 and 2. Both of them will be answer. So they will give marks to all. Okay. So, anyone has any doubt? Okay. See. Okay. Sarda is saying that only. So. Okay, wait a second. Okay, so much confusion. Let me answer this question. See, let me answer this question. Let's assume P is true. Q is true. Let's assume. Then this will become true, and this negation, finally this value will become false. This expression will become false. Okay. Now you just see. So this finally this expression will become false. Now you check the third one. Now you check. This P dash will become false, and this Q dash will become false. False double implies false is nothing but true. So you can see this third is not the answer. Okay, because you can see when you take P true, Q true, when you take both of them true, then your original answer is becoming false, but this option third is becoming true. Are you getting my point? Now you check this. If you take P true, if you take Q true, then this will become false. Now this complete thing will become false. So this is what we wanted. Okay, and if let me also draw this equation. Let me draw this. I told you this thing, that this P XOR see, this P double implies Q. This is same as P XNOR Q. See, P XNOR Q. What is P XNOR Q? I told you this is PQ plus P dash Q dash. Okay. Now let's see what is this. Let's check this. What is this? Let's check this. This is same as P XNOR Q dash. Now let's see. So this will become P. This will become PQ dash plus P dash Q. Okay. Are you seeing? So you can see this will become this. So, and our original equation is basically complement of this. Our original equation is complement of this, and the complement of this will become P dash Q plus PQ dash. Because I told you that if you have XNOR, then the complement of XNOR will become XOR, and XOR is nothing but P dash Q plus PQ dash. Okay, this is XOR. Okay, so this will be your original equation will be this, because original equation is, remember, original equation is P XOR Q. P XOR Q. Okay, so this is your original equation. This is your option 1. Similarly, you can try option 2. Option 2 will become P dash Q plus PQ dash. This will become your option 2. So option 2, option 1, both are correct. Both are equivalent to the given expression. Anyone has any doubt? Still anyone has any doubt? The answer will be option 1, option 2. Option 3 is not the answer. So you can prove very easily. You can prove it, or you can take truth table. You can prove it, or you can prove it by the formula. I have given you the formula. Or you can, if you want to remember the result, then you can also, if you want to remember, then you can remember that P XOR Q complement is nothing. Sorry, P XNOR Q complement is nothing but P XOR Q, and this P XOR Q is nothing but P dash Q plus PQ dash. Also, you can remember that if you change one of them, then the situation will not change. For example, this P dash XOR Q, what it will become? It will become if you change one of them, then situation will change, because if you do P dash XOR Q, then it will become PQ plus P dash Q dash, and this is nothing but your P XNOR Q. So all these things. Sir, but for by condition you said this is yes, Manisha, it is correct. Sir, I think truth table method is better to prove formula. The truth table method is definitely nice method, but it takes a lot of time. Okay, so that's why people don't generally use truth table. Okay. So anyone has any doubt in this? Okay, let's see this. Let me see question number 9. If anyone has any doubt on question number 8, then you can ask again. Just write a doubt and you ask your doubt. Okay. Now, negation of proposition. What is this? We have already seen this question, that the negation of this is nothing but for all x negation of hx. So finally you will get for all x negation of hx. Answer will be option 2. Okay. If anyone still has any doubt in this question number 8, then you can ask. Okay, in this question option 1, option 2 both are correct, option 3 is not correct, option 4 is not correct. Okay, and also the same question you will again study in the digital logic subject. There also you will study, so nothing to worry. In this subject you will again you will again encounter this type of question. Let me see more questions. Which of the following statement is true? So now he is basically saying that which of these statement, the sentence as is logical consequence of S1 if and only if. So this is the definition of argument. If you remember, this question is basically definition of argument. What is the definition of argument? We have already seen. In argument we have some statements. We have S1, S2, S3. We have some statements. Okay, some statements we call them hypothesis or premises, and we have a conclusion. Okay, and I told you that this argument is valid if and only if S1 and S2 and S3, all these things basically imply C. This thing must be tautology. So this we have already seen in arguments. If you remember, we have already seen this concept in arguments. So this question is same. The statement as is logical consequence of these statements if and only if this implies this is satisfiable. No, that is not correct. This should be basically tautology, means this should be valid. So answer will be option 2. The answer will be option 2. Is it correct? This is just the definition of argument. Okay, we have already seen the definition of argument. This is the definition of argument. Okay, is it clear? So very easy question it is. The answer will be option 2. If anyone has any doubt, any confusion, then you can ask, because after today's class I don't think that we will have time to come back to this mathematical logic again. Okay, so that's why I am forcing you to, if you have any doubt, then you can ask. Okay, because after today's class, if you will ask any doubt on the WhatsApp, then I can only answer that on WhatsApp. We can't take your doubt on the like this live lecture. Okay, let's see. The first order logic formula is equivalent to which of the following? Again the same very easy question. You can do the elimination method, or you can solve this complete thing. Let's solve this complete thing. R or Q and P or Q dash. This is your formula. Okay, what you do? Just actually, so too many equations are there, but anyway you can multiply it. So you just multiply this. Okay, these rules that we have seen in our mathematics. In our mathematics we see these kind of rules. If you remember, x plus y multiplied by y plus z, and then what we do xy plus xz plus y square plus yz. These kind of things, these kind of rules we have in our general mathematics. This kind of rule we also have in our mathematical propositional logic. So we can basically do the multiplication. So you will get rp. Now rp plus rq dash plus qp plus qq dash. Qq dash is nothing but false. You already know this thing. Qq dash is nothing but false. False plus anything is false, so this is false, so just remove it. This will be your answer. Rp plus rq dash plus qp. Where it is? Okay, so okay, again we have to do some modification here. Wait a second. The answer is given in the form of okay, so here the answer is given not given in that form. So what we can do, maybe we can try to eliminate the options. Why not both are? Question number 59, someone is asking. This is the definition. We have already seen that this should be valid. Valid means tautology. See valid, if something is valid then it is satisfiable, but if something is satisfiable then it may not be valid. So valid and satisfiable are not same thing, they are different thing. Okay, if something is valid, then that is satisfiable, but if something is satisfiable, then that is not valid. That's why this answer will be option 2. Okay, so okay, let's see this question. In this question, basically the best method will be to eliminate options. Let's take some values. For example, let's take r equal to let's take everyone false, then you will get this is false. And when we take everyone false, basically we take p false, q false, p, q, r, everything you take as false, then what you will get, this is your false and this is your true, because q dash, this q dash will become true. So anyway, this complete thing will become, the original formula will become false. Let's check which of them will become false. So this will become false, this will become false, this will become false. Anyway, okay, so this will not work. Now we have to check, do something else. So we can eliminate by, this question seems like a very lengthy question. P, okay, r plus and p or q. So actually, to solve this question, we can apply a property. If you remember, I gave you a property that if p implies q and q implies p, q implies r. So this we have already discussed, if you remember. If p implies q and q implies r, then p will imply r. This implication is basically transitive. Okay, this implication is transitive, means if p implies q, q implies r, then p will imply r. This implication is transitive. Okay, so you just look at this option. This I will write in terms of implication. Okay, this I will write in terms of implication. So this is very easy. I can write like this: q implies p. Okay, remember this thing, p or q dash. How can I write it? I can write like this: q implies p. Okay, now I will write this also. So how can I write this? Q implies p, and I can write like this: r dash implies q. Right? See, this r plus q, how can I write it? I can write it like this: r dash implies q. Why? Because you just see, this will when you convert it in this side, then what you will get? Basically r plus q. So this is how I can do. Now r dash implies q, q implies p, then what will happen? Then r dash implies p, because implication is transitive. Okay, so r dash implies q, q implies p, then what will happen? R dash will imply p. What is r dash imply p? R dash imply p means r plus p. So r plus p. So the answer actually, so just basically this r plus p. So that's why the answer will be option 2. This is how you can solve this question actually. If you solve this question by completely like then that it will become very lengthy. So the trick is that they have very nice question it is. Okay, just remember, we have already seen this, I think, that this implication is transitive. Basically this implication is transitive. What it means? P implies q, q implies r, then basically if p implies q and q implies r, then p will imply r. P will imply r. Remember this thing. Implication is transitive, means p implies q, q implies r, then what will happen? P will imply r. Okay, so implication is transitive. Now actually from the options I got to know that they have basically used the transitive property, because you see these two things are same, these two things are same, these two things are same everywhere, these two things are same. They have added additional information. So that additional information you can get from this transitive property. So what I did, I basically just represented them in implication format. Very easy. You can write this as q dash implies p. Q implies p. You can write this as q implies p. You can write this as r dash implies q. Okay, r dash implies q. Now r dash implies q, q implies p, then what will mean? It will mean r dash implies p. It will mean r dash implies p. So basically r dash implies p. How can I write it? I can write it r plus p. So basically this r plus p, that's why from this r plus p is coming from there. So that's why answer will be option 2. Anyone has any doubt? Sir, I solved it by argument and conclusion form. Yeah, yes, you can solve it by that also. Is this point clear? This is a nice property. This implication is transitive. This is a nice property. You can see this question is very nice question, which is using the transitive property of implication. Okay, the same question you can solve in many different ways if you want to solve it. But actually, whoever set this question, okay, whoever set this question, his intention was to basically use the transitive property of implication. Okay, of course you can solve the same question with many different methods. Okay, but you should now after seeing this solution, you should practice this solution. Okay, again you should try this question again. Okay, because this is a nice property. Implication is transitive. This is a nice property. Okay, now next question, in propositional logic, again this is again the transitive property. This is again, you see, P implies Q. No, sorry, no, this is not the transitive property. This is not the transitive property. Okay. No, because transitive property says that if P implies Q and Q implies something, okay, that is transitive. Anyway, in propositional logic, if this and this are premises, basically this and this are premises. Now he is asking which of them is conclusion. So he is asking conclusion. Okay, so basically he has given that P implies Q and R implies S. Now he is saying that P or R. See, okay, very easily you can solve it. The first premise, the first condition, the first hypothesis he has given is this: if P will happen, then Q will happen. If R will happen, then S will happen. And the second premise is that either P is happening or R is happening. See, okay, just look at it. Just look at this question. We are solving this question without using the method. With intuition, we are solving this question. See, this first hypothesis is saying that P imply, if P will happen, then Q will happen, and if R will happen, then S will happen. Okay. In the second hypothesis, he is saying that either P is happening or R is happening. What it means? Either P is happening or R is happening. What it means? See, if P is happening, then Q will definitely happen. If R is happening, then S will definitely happen. So either P is happening or R is happening, then what it means? Either Q will happen or S will happen, because either P is happening or R is happening. If P will happen, then Q will happen. If R will happen, then S will happen. At least one of them is happening. Then we can say that at least one of them is also happening. So we can say either Q is happening or S is happening. So the answer will be option 4. This is how you can very intuitively you can solve this question. Did you get this intuition? Of course you can solve this question by many different methods, but I just want to give you the intuition. Okay, did you get this intuition? Okay, so let's move on. If anyone has any doubt, you can ask. Let's see this question. What it is saying: Vx means x is vegetarian, My means y is meat, Exy means x eats y. Based on these, consider the following sentences. Okay, so now he has given some things. For all x Vx, double implies this thing. Means basically for all x Vx means everyone is vegetarian. Then basically this statement is saying that for all y, अगर x जो है वो y को खा रहा है तो वो y जो है वो meat नहीं है. For all x Vx is this. Okay, for all x this is equal to. So very easily we can solve this question actually. See, let's just look at the statement 1. Statement 1 you already have. Now let's see the statement 2. For all x Vx. Okay, double implies. Now see, in the statement 1, if I convert this implication, into our formula, if you remember this formula, P implies Q, then how can I write it? I can write P dash plus Q. So that is what I will do. So if you convert this, then this is your LHS. So basically you will complement it. Basically you will complement the LHS. This is your LHS, x y plus negation of my. Okay, see, I did nothing, but I have just taken the option 1. In the option 1 I have converted this implication like this, LHS bar plus Q. So this I will get. Now you know how to negate a quantifier. This you already know. So you will get there exist y negation of exy. This you will get plus negation of my. So you will get this. Okay. Now wait a second. So what is this? This is negation of there exist exy. Some confusion is there. There exist m, y and exy. Okay. So you will get this. There exist negation of exy plus let's solve this question by some different method. So the first statement is saying that everyone is vegetarian. That can also be written like this, that for everyone अगर खा रहा है y तो y जो है वो मीट नहीं है. Okay, this is correct. Now the option 2 is saying that the definition of vegetarian he has given that there does not exist a y such that वो मीट भी खा रहा है, वो y जो है वो मीट है एंड x जो है वो उसको खा रहा है. There does not exist a y. So this is not correct. Why? See, here actually in the second statement he is saying that there does not exist any meat in the world. There does not exist any meat. Okay, so this is not what we wanted. Of course meat should be there, means animals should be there, basically animals should be there, but everyone should be vegetarian. See, the statement 1 is saying that for every y, statement 1 is saying that for every meat, no, some mistake is there. Okay, let's do one thing. Let me think about it and we will see this in the next class. Okay, right now let's keep it pending. We will see this in the next class. I will give the answer in the next class. In the beginning of the next class I will give the answer. Let's quickly see the remaining questions. Okay, because it will take time to think about that question, and so that's why I'm saying that first let's cover the remaining questions, and this question I will take in the next class. Let me see if anyone has any doubt. Okay, so let's see this question. The boolean function is equal to which boolean function? A very easy question this is. Okay, nothing much, just some properties and just some things you need to apply. What is this saying? That first of all this is negation of, first of all what is this? You just solve it. What is this? This is nothing but p dash q negation, and okay, so let me write it here, p dash q negation, and what is this? This is p dash q dash negation, this complete thing, or pr. Okay, so this is now here you can what you can do, here you can apply the De Morgan formula, or you can just take, you can eliminate the options. Let's assume the q is true. Let's assume q is true. Then what will happen? If q is true, then if q is true, then this will become false and this complete thing will become true. So this is not the answer anyway, or we can solve using by the let's solve it using the De Morgan formula. So this will become p plus q dash, this will become p plus q dash, and this will become p plus q. Okay, this will become p plus q. Okay, so this complete thing, or pr. Now just multiply them, then you will get p multiplied by p, that is p, plus you will get pq, plus you will get q dash p, plus you will get qq dash. Qq dash is nothing but false. So this plus pr. I have already told you that P plus PQ is nothing but P. This we have already seen today. P plus PQ is nothing but P. So this complete thing is nothing but P. P plus PQ dash is nothing but P. So this complete thing again P. P plus PR is nothing but P. So this again is P. So the answer will be option 4th. Okay. Is it clear? Is it a very easy question? Just what we have done. First of all, we have applied the De Morgan formula, and then we just multiplied them, and then we used this equation that we have already seen. I told you this thing that P plus P and anything can be here, and the final result will be P. This we have already seen. So the answer will be option 4th. Okay. Anyone has any doubt? Let's see this question. And the time is about to over, so let me know when to finish, because I can teach for 1 2 hour more also if you want. So let me know if anyone want me to stop. Let's assume that you construct ordered tree to represent the compound proposition. The prefix expression, postfix expression, what will be? So actually this question is a question of you can say compiler design. In the compiler design you will, or in data structure you will study this thing, but anyway we can do this, we can solve this question very easily. What is this question saying? You represent it with a tree. So basically in the tree what will happen? See, it is happening like this. You have this expression, you have this expression, and finally you are doing this. So basically what you are doing, you have this operator, and in one side you have this expression. What is this expression? This expression you have basically LHS expression you have. In another side you have the RHS expression. Now let's look at the LHS expression. The LHS expression is negation of P and Q. So what you will do, basically you are doing the negation. You are doing the negation, and on negation of what? Negation of P and Q. Negation of P and Q. So and P Q. So this is how you can draw the tree. Okay, so okay, let me take different slide. Let me take this slide. So what is this equation? The equation is negation P and Q, negation P and Q, this double implication, negation P or negation Q, negation P or negation Q. So very easily you can draw the tree. The tree, what it will do, see, you have this LHS, you have this RHS. So first, basically at the end you will do this, and in this side you will have the LHS tree, in this side you have the LHS tree, in this side you will have the RHS tree. Now the LHS is this. How can I draw the tree for this? Basically at the end you will do the negation, okay, and this negation you will do. Now what are you negating? You are negating the P and Q. So basically you are negating the P and Q. So this is your LHS tree. Now let's look at the RHS tree. At the end you are doing the disjunction. At the end you are doing the disjunction, and this basically you are doing the negation of P, you are doing the negation of Q. So this is the tree that you will get. Anyone has any doubt in this tree? This tree we got from the precedence order. Don't worry about anything. We got this tree from the precedence order, because you see, first you will do this. First you will do this, then you will do this, then you will do this. So that's what we mean. Basically first we will do this, then we will do this, then we will do this. Okay, similarly here, first we will do the, because bracket has highest precedence, so first we will do the P and Q. First we will do the P and Q, then we will do the negation, and finally at the end we will do this by implication. Anyone has any doubt in this tree? Once we got this tree, then in data structure you will study something called prefix postfix. Now you can apply this prefix postfix. So in prefix what we do? In prefix we first write the root node, then we write the LHS, then we write the RHS. This is our prefix, this is our basically pre-order or prefix order, whatever. First we write the root node, then we write the LHS, then we write the RHS. So first we will write the root node. This is the root node. This we will write. Then we will write the complete LHS. So let's write the complete LHS. What is LHS? In LHS again the same thing we will do. First we will write the root. Root is nothing but negation. Now we will write the LHS, RHS, but of course there is only this one thing. So we will do the negation. Then we will do the PQ. So this is now this this left hand side tree is over. Now let's see this right hand side tree. So here what you will do, again the same thing. First you will write the root, then you will write the LHS and then RHS. So you will write this disjunction, then you will write the this and then this. So you will basically write negation P, negation Q. So this is how you will, this is the prefix order that you will get. So the prefix order that you will get is this. Let me see, and PQ or not P not Q, or not P not Q. So the answer will be this. So the answer you can so this is eliminated, this is eliminated, this is eliminated. Now we have remaining two options we have. Okay, two options are remaining. So now because you can see this pre-order, both pre-order are correct. Now let's write the post order. In post order, what we will do, in post order we will basically just opposite we will do. We will write the root at the end. First we will do the LHS, then we will do the RHS, and at the end we will do the root node. So this root node we will do at the end. Okay, this we will do at the end. First we will write the complete LHS, then we will write the complete RHS. Now let's write the complete LHS. In this LHS, again what you will do in this LHS, again what you will do, again you will write the root node at the end. Okay, so you wrote the root node at the end. So basically now PQ and this you will get. So, okay, is it clear? Anyone has any doubt, then you can ask. Now here also, now let's complete it. So here also you will write the root node at the end. Okay, first you will write the LHS. The LHS will be basically P negation and the RHS will be Q negation. So this is your answer, PQ and negation. So the answer will be PQ and negation, PQ and negation. Then you have P negation Q, then you have PQ and negation, P negation Q. So yes, so the answer will be option 2. You can just check it out. The answer will be option 2. Okay, so this is a question actually. This is a question of compiler design. In compiler design we draw something called syntax tree. So in previous question is PR is the answer. In previous question answer is P. In the previous question, in this question answer is P. We have solved this question using the De Morgan formula. We have tried this question, but you can solve this question by option elimination also. Actually, whenever you take this P equal to true, then this will be true. Whenever P is false, then this is false. So you can try this question. We have solved this question using De Morgan formula. You can apply the De Morgan formula and the answer will be P. The equation that we used here was like this: P plus PQ. What you will get? You will get P. This we have already seen today. I told you that P plus PQ is nothing but P. I told you that P plus P dash Q is nothing but P plus Q, because we will just remove this P dash. I told you P plus P is nothing but P. All these things we have seen today. Okay, so is this question clear? This is a question which basically compiler design plus data structure. This is a question of compiler design plus data structure. In compiler design we draw something called syntax tree. Okay, and in data structure we have something called prefix expression, postfix expression. All these things we have in data structure. So if anyone has any doubt, then you can ask. Let me take this question. What is this? This is again easy question. In propositional logic, basically the one hypothesis he has given is P. Another, this is a question of argument. This is a question of argument. Basically he has given a P, also he has given P implies Q. Then he is asking what you can say. See, this hypothesis is saying that if P is true, then Q is true. See, this hypothesis is saying that if P is true, then Q is true, and this hypothesis is saying that P is true. See, now you combine these two hypotheses. This hypothesis is saying that P is true, and this hypothesis is saying that if P is true, then Q is true. So if you combine them, then what you will get? You will get that Q is true. Just combine them. Are you getting my point? So the answer will be Q. But you can solve this question using our method also. What is the method? The method I told you, this P and this P implies Q, this complete thing imply Q. This must be tautology. I told you in argument, this must be tautology, this must be valid. You can solve this question like this also, or you can solve this question by our method, by our definition. So just check whether this is tautology or not. You will see that this is tautology. Okay, let's check this. First of all, what is it? It is P and P dash plus Q. Okay, implies Q. What is this? Inside, if you do this, then you will get PQ, because P dash is nothing but false. This is basically just just multiply this P inside. So what you will get? You will get P dash plus PQ. P dash is nothing but false. So finally you will get PQ implies Q. Now again you remove this implication, then what you will get? You will get PQ dash plus Q. Now you apply the De Morgan formula, then what you will get? You will get P dash Q dash, P dash plus Q dash plus Q. Q plus Q dash is nothing but true. P dash plus true. And you know anything plus true is equal to true. So finally you got true. True means tautology. So yes, finally we got true. So that's why the answer is option 2. Okay. So this is very easy question. Actually, intuitively you solve it. I am just saying that these argument questions you can solve very intuitively. You can solve. Just combine these two arguments. This is saying P is true. This is saying if P is true, then Q is true. If you combine them, then what you will get? You will get Q is true. So that's why the answer is 2. Anyone has any doubt? Let's see this. Again, some validity question. Again, some argument question he is saying. So let's see the first statement. What he is saying? If Gora gets the job and works hard, then he will be promoted. Okay. So basically he is saying that if Gora gets the job and works hard, then he will be promoted. He will be promoted. Okay. So this is the first hypothesis. Another hypothesis is, if Gora gets promotion, then he will be happy. The another hypothesis is that promotion implies happy. He will not be happy, and basically the third hypothesis is that he is not happy. This is the third hypothesis. He is not happy. This is the third hypothesis. Finally, this is the conclusion. Remember, the conclusion is always followed by the therefore. This word, this English word therefore. This therefore word will basically, it is saying that the remaining statement is conclusion. So this is our conclusion. What is our, so these are the hypotheses. Now what is our conclusion? Our conclusion is either he will not get the job or he will not work hard. Means either he will not get the job or he will not work hard. This is our conclusion. So very easily you can check. So see, just combine all these hypotheses. This third hypothesis is saying that he is not happy. Means H is false. Means H is false. Happy, he is not happy means H is false. See, if H is false, then what it will become? It will become, if H is false, then P is also false. Why? Because you see, P implies H. What you can write? You can write P dash plus H. Now, if H is false, then P dash plus false is nothing but P dash. So this P implies H, it will become P dash. Means if H is false, then P is also false. Means if he is not happy, then P is also false. So this P is also false. Now, if P is false, then this is also false. Means this J and W, this is also false. This is also false. Means basically this, I can say this. Then this is nothing but you just apply the De Morgan formula and you will get this. So anyone has any doubt right now in this? You see, I solved this question using our intuitive method. Okay, I just took all the premises and then I just saw what it will become. So you can see this is a true argument. This is a valid argument. In the question he is saying which is not valid. So A is valid. So the answer cannot be this, answer cannot be this, answer cannot be this. Answer will be option 2. You can see why. Because in the question he is saying which of the following argument is not valid. Not valid. The argument A is actually valid. The argument A is valid. So you can say the answer will be B and C. None of the options were matching when I solved it. Okay. So Khushbu, I just so far I have only solved option A. and option A is valid. Option A is valid. So that's why I did not check B or C. Let me check B or C. Let me check this B. What is this B? B is either Puneet is not guilty or Pankaj is telling truth. So basically what it is saying either Puneet is not guilty. Okay, so Puneet not guilty or Pankaj is telling the truth. Okay, Pankaj telling truth. Now Pankaj is not telling the truth. He is saying Pankaj is not telling the truth. Pankaj is not telling the truth. Pankaj truth. Not now. Then the conclusion is Puneet is not guilty. So very easily you can see. So you see this hypothesis. What is this hypothesis? In this hypothesis he is saying that Pankaj is not telling the truth. Means this has become false. This has become false. Means this has become false. This has become false. Now if this has become false, then this should be true. Means Puneet is not guilty. This should be true. So yes, this is true. So this is also valid actually. B is also valid. A is also valid. Okay. Let's see option C. Option C is saying that if n is real number such that n greater than 1, then n square equal to then n square greater than 1. Suppose that n is square greater than 1, then n is greater than 1. So in this question we have these hypotheses. The first hypothesis is that if n is real number such that n greater than 1, then n square. So this is first hypothesis. In this first hypothesis, what he is saying? He is saying like this: n greater than 1 implies n square greater than 1. This is the first hypothesis. What it is saying? It is saying that if n greater than 1, then n square greater than 1. This is our first hypothesis. And the second hypothesis is that n square greater than 1. And our conclusion is that n greater than 1. This is our conclusion. Okay, this is our conclusion. Now let's see. So he is saying that this is true. Means this is true. The thing is, if this is true, then automatically this complete thing will become true. We don't need this n greater than 1. So that's why actually this is not a valid. Are you getting my point? So Sukhpreet is asking to explain this option C. In option C, Sukhpreet, we have two hypotheses. The first hypothesis is this, means n greater than 1 implies n square greater than 1. This is our first hypothesis. And the second hypothesis is n square greater than 1. Okay, and the conclusion is n greater than 1. The conclusion is n greater than 1. Now let's look at this. See, here in this hypothesis he is saying that n square greater than 1 means this has become true. This has become true. Now if this has become true, then automatically I told you that P implies Q. If this becomes true, then automatically this complete thing become true. Okay, so when this Q will become true, then the P does not matter. P can be true, P can be false. So P does not matter. So remember, when this n square greater than 1, when this will become true, then it does not matter. It does not matter whether it is true or not. So we cannot say that this is always true. Are you getting my point? So we cannot say that this is always true. So that's why this option C is not valid. Okay, so some students are saying that option B. Should I check option B again? In this option B, he is saying that either Puneet is not guilty or Pankaj is telling the truth. Pankaj is not telling the truth. See, this hypothesis, just look at this hypothesis. In this hypothesis, he is saying that Pankaj is not telling the truth. Pankaj is not telling the truth means this has become false. This has become false. Okay, because Pankaj is not telling the truth. So this has become false. Because this has become false, so this should be true. Because this is a disjunction, you can see. This is a or. So if this has become false, then it has to be it has to be true. Means Puneet is not guilty. And this is the conclusion. Puneet is not guilty. This is the conclusion. So this is a valid argument. Is this point clear, Amandeep? Amandeep, is it clear that this is a valid argument? Should I explain again? Let me know if you want me to explain again. This is a valid argument. Amandeep. So this is valid, this is valid, this is not valid. Option C is not valid. Actually, no option is. So this in this question, no option is matching. No option is matching in this question. Okay. Amandeep, let me know if I should explain again or not. No, in the question he is asking not valid. In the question he is asking not valid, not valid. But A is valid, B is valid. In the question he is asking not valid. So because he is asking not valid, so the answer should be C only. Answer should be C only. That's why no option is matching. Okay. Nivedita is asking option A again. Okay, let me check. Let me take option A again. Let me take it again. So in option A, Nivedita, see, the first hypothesis is this. Look at this first hypothesis. This is the first hypothesis. Means if Gora gets the job and works hard, then he will be promoted. What it means? It means job and work hard implies promoted. Okay. Now this is the second hypothesis. If Gora gets promotion, then he will be happy. Means promotion implies happiness. Okay, promotion implies happiness. Now this is the third hypothesis. He is not happy. Basically, he is not happy. He is not happy. This is the third hypothesis. And the conclusion is he will not get the job or he will not work hard. The conclusion is he will not get the job or he will not work hard. This is the conclusion. Okay. Now again, do the way I am doing. Just look at the way I am doing. You take this because this is very easy, because this is only involving one variable. So you just look at it. This is our hypothesis. In this hypothesis, what he is saying that Gora is not happy. Basically, this is saying not happy. Negation of happy. Negation of happy means not happy. Not happy. Not happy means happy has become false. Means this has become false. See, not happy means happy has become false. So this has become false. Because this has become false, so we know this thing. Whenever we have P implies Q, and let's assume Q is false, then this complete thing is nothing but P dash. Why? See, P implies Q is nothing but P dash plus Q. This P implies Q is nothing but P dash plus Q. P dash plus Q. If Q is false, then false plus P dash. False plus P dash is nothing but P dash. So if H is false, then this complete thing will become P dash. P dash means not promoted. Not promoted means this has become false. Not promoted, then this has become false. This P has become false. Okay, because P dash is true, means not promoted. P dash is true, so it will mean that P is false. So this P is false. Because this P is false, then this thing will become false, means J and W, this will become false. From here, you see, this is LHS, this is RHS. If RHS is false, then LHS will become false. Okay, this is what I want to say, because whenever this RHS is false, then automatically we can say that LHS is false. Now our LHS is J and W, so this will become false, means J and W complement. What is J and W complement? De Morgan formula, you apply it, you will get J complement or W complement. And this is our conclusion. You can see J complement, W complement. This is our conclusion. So this is a valid argument because we got our conclusion. Nivedita, any doubt here? Any doubt in this? So this is how you can very easily you can solve these questions, these argument questions. You can solve very easily by doing this kind of analysis. So this type of analysis you can do very easily. You can do this analysis. So okay, let's do one thing. If you did not get this, actually I have explained this. I have explained all these three statements. I have already explained. If you did not get something, then you re-watch the recording. Okay. After re-watching the recording, if you still do not get it, then let me know. Okay, then you can ask me. Okay, I will give more explanation. Okay, so for this question, no option is matching because only C is invalid. A and B are valid. Let's see this question. Okay, a little bit tired I am feeling. So shall we continue? Can we solve B option using truth table? Yes, of course you can solve the option B using truth table also, but it will take time. You can try this. It will take time. That is the only thing. It will take time, and in exam you don't have that much time. So that's why this method, the method that I gave you, you can see I solved all these three questions by the same method. This question, this question, this question, all these three methods, in all these three questions I have solved them using the same method. Okay, so three questions on same method. You can practice more, you can practice this method more. This method will save a lot of time. Okay, this method that I have given you, I have solved three questions on this by the same method. So it's just a matter of practice. You solve more questions. Okay, you do more practice and you will get it. Okay, so let's see more how many questions are remaining. Let me check how many questions are. Give me 1 minute. Let me check how many questions are remaining. Still we have 1 2 3 4 5 6 7 8 9 10. 9 questions are remaining. Okay, 9 questions are remaining. So okay. So let me give you quick idea. Okay, let me give you quick idea of how to solve all these questions. Let me just give you quick idea. After this, maybe you can try your own on your own, and you can let me know if you have any doubt. So let me give you a quick idea of how to solve these questions. What is this? This is PMN. PMN means M divides N, where the universe means domain. Domain is universe of discourse for both the variables is set of positive integers. Determine the truth value of the following propositions. See the basically he has given that PMN. What is the meaning of PMN? PMN means M divides M. M divides N. This is the meaning of PMN. M divides N. And the domain is given to you as set of positive integers, means 1 2 3 4. Set of positive integers is your domain. Okay, this is your domain for both the variables, for M, N. Basically this M will take value from set of positive integers, N will take value from set of positive integers. Okay, this is the meaning. Basically universe of both the variables is set of positive integers. So this is our universe, this is our domain. Now he is asking the truth value of these sentences. First let's see this. What it is? It is for all n p1n. What it means? It means for every number 1 divides n. Yes, this is true, because 1 will divide everything. You know this thing, because this is true. See what it is saying. It is saying for every number 1 2 3 4, for every number 1 divides that number. For every number 1 divides that number. This is true, because 1 will divide everything. So this is true. Okay, let's see this. What it is? In this is he is saying that there exists a m for all n PMN. Means basically he is saying like this: there exists element m such that for everyone this m divides n. Means this m will divide n, this m will divide n, this m will. Yes, this is true. Why? Because this m you can take to be 1. You can take this m to be 1. You know this one will divide everything. This 1 will divide everything. So this is the meaning. So this is also true, because this statement is saying that there exists m for all n, m divides n. So there is at least one element, and that element you can take as 1. So 1 divides everything. So this is also true. Let's see what is this. For all n p divides m. So this is not correct. Option C is not correct, because here it is saying that for every pair, whatever pair you take, m divides n. But this is not true, because for example you can take this pair 3, 4, you can take this pair, I told you, if you remember, I told you when we were discussing nested quantifier, there I told you what is the meaning of for all n, what is the meaning of this thing. So I've already told you. the meaning of this thing is that for every pair, okay, for every pair this is true. What is this? This is m divides n for every pair. Let's take this pair. 3 does not divide 4, so for this pair 3 comma 4, this has become false. So you can say that this is false, because option C is saying that for every pair Pmn must be true, but this is not the case. You can see, जब आप 3,4 जब आप ये लोगे तब क्या होगा? P3,4 will become false because 3 does not divide 4. So that's why, so we got true, true, false. So the answer will be true, true, false, true, true, false. Answer will be option 1. Okay, you can try this question. Now, okay, so someone was asking Vekas proof, trivial proof, and all these things. Someone was asking. Let me answer this question now. So let me answer this question. Wait a second. Let me have some water. Okay, so now let's see this question. Vekas proof, trivial proof, direct proof, indirect proof. So see, what is Vekas proof? Yes, what is Vekas proof? You can just today you can go and Google the English meaning of Vekas. The English meaning of Vekas. Okay, you can Google the English meaning of Vekas, and the Vekas proof means, for example, if you have, let's assume you have P implies Q. Let's assume you have this statement. This statement basically says that if P is true, then Q is true. This statement, if you see this statement, then this statement says that if P is true, then Q is true. Remember, this statement does not say anything about what will happen if P is false. This statement does not say anything about the situation in which P is false. So if P is false, then this is automatically true. I told you this thing, this P implies Q. I told you that if P is false, then automatically this thing is true. So this is what we mean by Vekas. Vekas means basically because you have not, for example, let's assume I do not make any statement about, let's assume, politics. Let's assume I do not make any statement about some movie. Okay, for example, right now everyone is boycotting this movie Sadak. Okay, this movie Sadak, whole India is boycotting this movie. Now let's assume that I do not say any statement about this movie. If I do not say any statement about this movie, okay, then basically you can think anything. Because I have not expressed my opinion. मैंने अपना opinion ही नहीं बताया, तो अब आप कुछ भी मान सकते हो मेरा opinion. That is what we mean by Vekas thing. क्योंकि अगर मान लो मैंने बोला ही नहीं, मैंने कोई ओपिनियन ही नहीं बताया कि ये सड़क मूवी अच्छी है बुरी है, मैंने ओपिनियन नहीं बताया, तो आप कुछ भी मान सकते हो कि ओके दीपक सोचता है कि सड़क मूवी अच्छी है, दीपक सोचता है सड़क मूवी बेकार है, तो आप कुछ भी मान सकते हो. दिस इज द मीनिंग बेसिकली. इफ P is false, then automatically this complete thing will become true. This is the meaning of Vekas truth, Vekas proof. So you can see, for example, this Vekas proof means implication is true based on the fact that P is false. So yes, this one is safe. Okay, so this A means 1. This A will go to 1. This A should go to 1. So the answer should be 1, I think. Let me check again. Trivial truth. The trivial truth. Yes, this is trivial truth. Yes, so because trivial truth, what is the trivial truth? So you see, did you get this? Vekas proof means if this is false, then automatically this complete thing will become true. This is Vekas proof. And what is the trivial proof? Trivial proof means, let's assume you go to college. Okay, आप IIT IISc में जा रहे हो अगले साल, और वहाँ पे जाके आप कुछ ऐसा प्रूव कर रहे हो जो ऑलरेडी प्रूवन है. वहाँ पे जाके आप प्रूव कर रहे हो 2 + 2 = 4. ओके, वहाँ पे जाके आप ये प्रूव कर रहे हो. तो दिस इज अ ट्रिवियल प्रूफ बिकॉज दिस इज ऑलरेडी प्रूवन फैक्ट. तो मान लो कि आप Q को प्रूव करना चाहते हो, लेकिन Q ऑलरेडी प्रूव है, तो इसका मतलब क्या है कि वो ट्रिवियल प्रूफ हो गया. तो ये हो गया बी का सेकंड. ट्रिवियल प्रूफ मीन्स यू आर प्रूविंग समथिंग विच इज ऑलरेडी ट्रू, विच इज ऑलरेडी प्रूवन. ओके, So that is the meaning of trivial proof. What is the direct proof? The direct proof is a proof implication that proceeds by showing that Q must be true when P is true. This is direct proof. So in direct proof, basically you are going in forward direction. That is the direct proof. Means you are basically showing that Q is true from P. Basically you are saying that if P is true, then Q is true. That is the direct proof. Means you are going in the forward direction. Indirect proof, what is indirect proof? Indirect proof means you are going in the backward direction. You are saying that if Q is false, then P is false. That is the indirect proof. So the answer will be option 1. If anyone has any doubt in this, then you can just Google the meaning of vacus. Just Google the meaning of vacus. Okay, Google the meaning of trivial, English meaning of trivial, and direct, indirect. So direct means you are going in the forward direction, and indirect means you are going like this. You are going like this. So direct means you are going like this, indirect means you are going like this. So the answer will be option 1. This question you can very easily solve it, so I don't need to solve it. Tautology he is asking, so just solve this question, very easy. This question I can leave this question. Okay, now what is this? The closure form of disjunctive normal form is again a very easy question. He has given you this thing. This is nothing but, we have already solved this question. If you remember, this is nothing but ABCD complement. This statement is nothing but ABCD complement. Okay, this is nothing but ABCD complement. So this statement will be true when ABCD will be false. When ABCD will be false, so answer will be fourth, because this given statement is nothing but ABCD complement. So this given statement will be true when ABCD is false. So the answer will be option 4. Next very easy question. He is saying, and I have already explained you. See, this double by implication is nothing but XNOR, and this XNOR is nothing but PQ plus P dash Q dash. So what is the answer? PQ plus P dash Q dash. PQ plus P dash Q dash. So the answer will be PQ plus P dash Q dash is equivalent to, I think the answer will be this. Yeah, the answer will be this. Yes, so answer will be option 4th. Okay, because you see, what is option 4th? In option 4th, this is nothing but Q dash P dash using De Morgan formula. Using De Morgan formula, this will become Q dash P dash plus. I am just converting this implication into plus. Then this will become P plus Q. Okay, no. This is P plus Q. So this option is also not correct. Actually, this should be and here. This should be and here. Which of them is correct in that case? Okay, yeah, option B. Option B you check. Option B you check. You just multiply them. Option B, option 2 you check. Okay, so option 4th is not the correct, because in option 4th actually this should be like this. If this is like this, then option 4th should be correct. Okay, then option 4th would be correct if this is like this. But right now this option 4th is not correct. You can check option 2. What you do? Option 2 is like this: P dash plus Q multiplied by Q dash plus P. You just multiply them and you will get P dash Q dash plus P dash plus Q dash plus PQ. This is false, this is false. So finally you got PQ plus P dash Q dash. And I told you this is nothing but P double implies Q. So answer will be option 2. Answer will be option 2. Okay. I am just telling that, I am just saying that instead of this disjunction, if this is conjunction, then this option 4th will also be correct. If instead of this disjunction, if we use conjunction, then this also will be correct, this also will be correct. But right now for this question, the option is answer 2. In previous question got 1. In this question, what is the problem? Okay. There is a okay. Sorry. I thought that this is I gave the answer for this. Okay, sorry, but this is not this. So we can actually say like this: A, B, C, D dash complement. This formula is actually this: A, B, C, D dash complement. This is, so this given formula will be true when this is false. When this is false means A, B, C, D dash, when this is false. Okay, so So the answer for this will be A. So the answer actually will be this, option A. Why? Because you can see this option. You just see this option A. What is the option A? ABC implies D. So you can write like this: ABC complement plus D. What is ABC complement? That is nothing but A dash plus B dash plus C dash plus D, and this is our given formula. So the answer will be option A. Okay, actually I gave answer fourth because I thought that this is negation D. If this is negation D, if this is negation A, negation B, negation C, negation D, if this is like this, then answer will be option fourth. But right now, because this is not, because this is D only, so the answer will be option 1. Because very easily you can just take the option 1 and you can convert this option 1 using our formula. Okay, this will become basically this dash plus D, and this dash will become this. Is it clear? Okay, thank you Khushbu for pointing it out. Actually I thought that this is negation D. So for this question answer will be option 2. But remember, you can try that if this is conjunction, then this option 4th will also be true. Okay, next question. So this next question is nothing but the basically we have to convert this given statement, English statement, into our formula, this formula. So what it is saying? He is saying that if my computations are correct and I pay the electric bill, then I will run out of money. So if my so basically he is saying like this: if my computation is correct and I pay my electric bill, then I will run out of money. So basically C and B running out of money. Okay. The second statement is if I don't pay electric bill, means negation of B, the power will be turned off. The power will be turned off means negation of P. Okay. Now the next, their conclusion is if I don't run out of money, means negation of R, and the power is still on P, then basically implies that my computation is incorrect. This is our conclusion. So the answer will be option 1. You can check, answer will be option 1. Very easy question. Just given English statements, you need to convert these English statements into mathematical formula. This is very easy question. No Khushbu, it is not a big question, it is a very easy question. Just you have a paragraph and you just need to convert this given English statement into mathematical logic formula. So the answer will be option 1. And what is this? Oh, what is this word? From where these NET people are taking this? I have never heard about this word. I have heard about this word. Anyway, so first of all, this is contrapositive. This we have already given. P implies Q. I told you that contrapositive of P implies Q is nothing but negation Q implies negation P. This is the contrapositive. If this is original statement, then this is contrapositive. So this is our contrapositive. A will go with 1. Actually, you can solve this question here only. Answer will be this. Very easy. You just solve this question here only because A will go with 1. I told you this thing. If you have original statement P implies Q, then converse will be, this will be converse, this will be inverse, and this will be contrapositive. I told you this thing. And we know that original statement is equivalent to its contrapositive. This also we have covered. We have already covered this topic. Okay, converse, contrapositive, all these things. And we have seen that every original, this is original conditional statement. This is equivalent to its contrapositive. So this is P implies Q. This is negation Q implies negation P. This is contrapositive. So answer will be option 1. You can very easily just answer it. And of course, other things you can do. For example, this is equivalence. This D will go with 4th. Okay, and other things. All these these exportation, and I have never heard about these names. But it is a good thing that you can solve this question just by matching A with 1. Also, you can match with this D with 4th. Because this is equivalence. I told you this operator, basically this operator is has the meaning of equivalence. Basically P is equivalent to Q. This is the meaning of this operator. This operator means equivalence. P is equivalent to Q. Okay. Again, this is a very easy question. Just you need to complement. So when you complement quantifier, then you will get there exists x negation of fx. So this you will get. So the answer will be option C. Very easy. Just complement the quantifier and you will get answer option C. What is this? The resolvent of the set of clause is set of clauses is. So these are statements that they have given. Okay, this is the one statement, and A dash or D, this is another statement, C or B dash. So these three statements are given. He is asking conclusion. Basically this means resolvent means basically he is asking conclusion. What is the conclusion? What is the conclusion you can make? So from these, what conclusion you can make? See, he is saying that either A is true or B is true. Okay, this is saying that basically this is saying that A implies D. If you see, this is saying that B implies C, and this is saying that A or B. We have already solved this question today. See, this is saying that A implies D, this is saying that B implies C. If A is true, then D is true. If B is true, then C is true. And he is saying that either A is true or B is true. Either A is true or B is true. Then what it will mean? It will mean either C is true or D is true. Either C is true or D is true. So actually this the resolvent is nothing but conclusion. So remember this, resolvent is nothing but a conclusion. Basically he is asking what is the conclusion you can draw. So when you have this these three statements, then the conclusion that you can draw is this C or D. This we have already seen today. If you remember this question we have already seen today. Earlier also we have seen it. There also I have solved this question. If you have any doubt, then you can ask. Let me see. So okay, this question we have already solved. Okay, okay, correct. So finally we have seen all the questions. One question is pending. I told you that one question we left pending, so that question I will answer tomorrow. We have seen all the questions. You can ask if anyone has any doubt, then you can ask right now. Anyone has any doubt? Amandeep is saying that too tired, extremely tired. Just think about me. I have been continuously speaking for last 3 hours. So okay, now I will take a lot of rest. If anyone has any doubt, then you can ask right now. Or you can do one thing. If you lost somewhere, what is trivial proof? देविका, ट्रिवियल प्रूफ का मतलब है आप कुछ ऐसा प्रूव करने की कोशिश कर रहे हो जो ऑलरेडी प्रूवन है. ठीक है. अगर मान लो कि मैं बोलूं कि मान लो कि आपने IIT ज्वाइन किया. IIT जाने के बाद में वहाँ पे आप रिसर्च कर रहे हो और उस रिसर्च में आप प्रूव कर रहे हो कि 2 + 2 = 4. लेट्स अज्यूम आप ये प्रूव कर रहे हो, तो ये तो ऑलरेडी प्रूवन है. ठीक है. तो इसे हम कहते हैं ट्रिवियल प्रूफ. ट्रिवियल प्रूफ मीन्स कुछ ऐसा जो कि मतलब ऑलरेडी प्रूवन है. ठीक है. सो एक्चुअली हमारे मतलब मेरी जो लैब थी वो ग्राफ थ्योरी लैब थी. उसमें हमने मतलब 3 रिजल्ट हमने प्रूव किए थे, और वो जो 3 रिजल्ट नए रिजल्ट थे, मतलब वो अभी तक किसी ने प्रूव नहीं किए थे, हमने प्रूव किए थे वो 3 रिजल्ट. और उन रिजल्ट्स के लिए हमारे प्रोफेसर जो हैं वो बोलते थे कि दीज आर नाइस रिजल्ट, दीज आर नॉन ट्रिवियल रिजल्ट, नॉन ट्रिवियल रिजल्ट. नॉन ट्रिवियल रिजल्ट बेसिकली माई प्रोफेसर वॉज सेइंग दैट these are those results which no one has proved yet, you have proven. So this is the meaning of non-trivial proof. Trivial proof means you are proving something which is already proven. Okay, Devika is asking, Devika, were you sleeping at that time? This question we have already discussed. Vekas proof, direct proof, this question we have already discussed, I think. See, you can rewatch the recording. This question number 8, I have already discussed about it. Devika, did you attend when I was discussing this question? Did you attend this session? I think you were not there at that time. So Devika, you can rewatch this. I have already proven it. I have already solved this question number 8. I have already solved this question. You can rewatch the recording. Okay. I have already I have already given the definition of Vekas proof, trivial proof, direct proof, indirect proof. All these I have already given the definition. Okay, just rewatch the recording and you will get it. Okay, no problem. Just re-watch the recording are already available to you, and you can re-watch them anytime. So this question number 8 I have already discussed. Okay, so this question number 8 has been discussed. Okay, Amandeep, now you can go and you can make your daughter sleep. So I will also go and have some dinner or something. Okay, thank you everyone. Let's meet tomorrow for the next new chapter, group theory. Tomorrow we will take the next chapter, that is group theory. You can solve questions, you can practice. If you have any doubt, then you can ask anytime. Okay then, bye everyone. मुझे भी भूख लग गई है खुशबू, मैं भी अब खा